Pretty simple, right? Okay, so stand up if you're paying attention. Whoop. I see some people are stuck at the back. Okay, thank you so much. Please sit down. So I see 2 people are still stuck there, okay? All right, so second statement. Stand up if this Saturday is something you're looking forward to. Fantastic. All right, please sit down. Thank you. Right, third statement. Stand up if you had your coffee or tea this morning. Okay, there are some people who didn't. Clearly, they need to. All right, please sit down. Thank you so much. All right, so I'm going to move with a little bit harder questions or maybe something a bit more challenging for you. So stand up if this is the first time you've been here in Google Malaysia. Wow, welcome. Wow. Okay, thank you. Please sit down. All right, stand up if you've been working at least for 1 year. Hesitating a little bit. All right, great. So we have a few students, I see. All right, fantastic. Please sit down. Stand up if you've been in tech for at least 1 year or working in relation to tech. Okay, fantastic. Thank you. And next question is stand up if you want to venture into tech. Want to, meaning you're not, but you want to. Okay, great, fantastic. So now you have seen those who are already in tech and those who want to venture into tech, right? If you look around, you can see the different people from all walks of life. And I just want to say that this is a great opportunity for you guys to network while you're here. Not just being here for the sake of being here, but also learning and, of course, taking the advantage of networking with people who are here today. So without further ado, my name is Alia. So I'm actually a learning experience designer in Inspire Group. So the company is actually based in New Zealand, but we extended a little bit into Australia and Malaysia. Today we have the Google I/O extended to Kuala Lumpur. So I wanted to invite Vandik to do a little bit of opening and, of course, introduce you to the day.
Right, good morning. I'm Vandik from GDG Cloud KL. I'm the co-organizer. So it's great to see so many people came today, and most of you are actually first time coming to Google Malaysia. So yeah, hope you enjoy the view. You know, I mean Google Malaysia office decoration, everything. I pretty like it, the interior design. So yeah, okay. Without further ado, I think or maybe I explain a bit about the event. So today we are going to talk about iOS standard. We invited speakers from multiple different fields actually. So they will share about more about today the track is more about data and machine learning in cloud. So hope you enjoy the session. Yeah, without the further ado, I'll pass on to Michael for the keynote. Yeah.
Thank you. All right. Hold on, yeah. Okay, for those of you, many of you are the first time here in the office, welcome. We have quite a nice office. Our office area is also at level 20, but feel free to check out the facilities here. People like to take photos, put your Lego workmanship outside. Don't hesitate. It is meant for that, right? Okay, so allow me to introduce myself. I lead the customer engineering team here in Malaysia for Google Cloud. I have two awesome engineers here in my team. Let me just quickly call them out then, but you'll hear from them later. Number one, Kiwi. So Kiwi, Yeah, come on, give me my hand. All right. So Kiwi helps the digital startups in Malaysia build their stuff. All right. So then the other person we have is Arvin. Arvin, just yeah. Arvin is our guru in analytics and now all things AI as well. Right. Great. So we have a growing team here, and I know that a lot of students are coming out of university and you want to get into tech. Never a better time. Never a better time, and it's a very rewarding career. Now, um, when earlier when you said more than 1 year, of course I hesitated. I said, "Wow, I've been here for 20 years in tech." So I didn't know what to do. I did. I felt that what was it for me? The question, but don't get fooled by Kiwi and Arvin. They're as old as I am. so it's been a very rewarding career in tech. More so because of the dawn of AI, generative AI. And I will touch a little bit about that in a bit. So let me just now let's start with something funny, right? Fastest things on Earth. You have the cheetah, fastest on land, airplane in the air, speed of light, and people becoming experts in AI, right? Why is that funny to some of you? Why? Why are you laughing? No. But it's true. When a new domain suddenly explodes, everybody, because we're a knowledge economy, right? We want to know answers. So all of us, in some way or another, will start trying to understand, trying to figure things out. And when you find yourself, hey, I'm in a group of people that I know a little bit more, suddenly you become the natural expert to the group of people. And that's very common. And why is this funny? Because it is true. And people are trying to get ahead in terms of, hey, I have certain skills and knowledge that can be useful, right? So you all should have that motivation as well. Okay. Now, who is this? Anyone? No, just shout it out. Anyone? Sorry, too old for you? You don't know him? Okay. Oh, we've got some goodies here. Hold on. Malaysian crowd is always like that. You see, all of you are laughing because you all know it's true. Okay, who is this? Don't use Google Lens and try. Horrible. Horrible. Anyone? Try to make a guess and I'll give you a sock. Socks. Pair of socks. Okay. Okay, no socks for anyone, but this is Tim Berners-Lee. Sir Tim Berners-Lee. You know who is Sir Tim Berners-Lee? The founder of the World Wide Web. The founder of the internet, guys. All right. And fastest person, who is this? I don't know, from here, you'll just catch. Okay. So, how is it that you all know Steve Jobs, but you don't know the founder of the internet? Why? No, nothing to do with age, my dear.
Steve Jobs has too biographical.
Because of the film that you know him. Okay. All right. Use Apple. Any guesses why? Why? Is it his character? Okay. So there's a reason why I set it up this way. Arguably, Sir Tim Berners-Lee's contribution should far outweigh Steve Jobs. Without the internet, you have nothing today, right? But that's the reason. So one of the questions that I want to pose for you all to consider today, when it comes to technology, all of you are from different generations. Some of you are from the mainframe generation, if you all know what mainframes are. Anyone from the mainframe generation? No? Oh, Unix generation? The web application generation, mobile app generation? No? Data, and yeah? We are all from different generations. We're all from different generations, and at every generation, you are going to have a tech that is going to change the world. If you look at today, the internet was a big, big shift. And then after that is the mobile. And then now it's AI. So the idea for you all to think about, for you all to take away today is, where does value accrue and who reaps the benefit? Why is it that Steve Jobs reaped the benefit but not Tim Berners-Lee? Right? So there's a very beautiful model built by Joel Monegro. It's called a fat and thin protocol layer. Now, I just want to impart certain things to you all. So if you look at this model, right, the y-axis is value that is captured. Value as in a sense of very simple, don't overthink it. Value means money, means business growth, means adoption, means that everybody loves it, everybody finds value in it. The x-axis is there's nothing, right? So if you look at the internet, the web generation, the protocol layer is the HTTP, SMTP, your feeds and speeds, how fast your line is. And then the application layer is your iPhone. You know iPhone, right? You all know Google Maps, Uber, search, etc., etc. So the web generation, the value was accrued at the application layer. Now, for those of you who are as old as I am, when the web started, we were buying, no, I didn't buy web domains. You all buy web domains? You too, young man? Oh, no, sorry. Not you, but you see, look at him. Young man buy web domains. You bought web domains. Not that young. All right, good. So that was the internet generation, right? And then telcos were trying so hard to say, I have the fastest line. Today they still do that. But that's not where innovation and value has happened. And you know where, looking at history for the past 20 years, you know where value has accrued at the application layer, even today. Agree? Yeah. So interestingly, when we look at blockchain, the reverse is true. So past 12 years, we have been, some of you, following Ethereum versus Bitcoin versus whatever, like nobody's business, right? How many of you are investing in Bitcoin right now? As we speak, you're just selling and buying. Hey, don't laugh, don't be shy. Just be yourself. Yeah, I'm selling a lot of stuff now. Past 12 years. The protocol layer in blockchain has been where the value has accrued, not the application layer. Interesting, right? Can you all name me a killer app on blockchain today? It's like, wow, 20 million people using. Anyone? Except for the trading app. Anyone? Any blockchain app that you know that, wow, amazing? No, right? So what I'm trying to paint here is, when you represent your company, where you apply the technology is super critical, because you want to apply it where it brings value to your business. You want to apply it where value will be accruing in the next 5-10 years. You don't want to be investing in the, wow, I'm a super killer blockchain app, but actually it has not picked up, right? So super important to think about, what about generative AI? Anyone? Y'all know generative AI? If you don't know, it's okay. We can just do a quick one. What's the difference generative AI and AI? Anyone? I give you a pair of socks. Any brave souls to answer wrong? It doesn't matter. You get a pair of Google developer socks. It's real. I'm not. Oh, okay. Maybe this lady. Yes.
When we interact with the AI gets that we feed the AI more info, then it generates content. So that's the generative AI.
Okay, I'll give it to you
Okay.
for being a brave soul. You want to try?
One actually learns from patterns, one actually generates the new patterns.
Okay. Ooh, can you all hear the wow? Ooh. Am I running out of stocks? Okay, very soon. Yeah, so the fundamental difference in AI is, you think about Google Translate is an AI. You put an input, you get an output. Whereas generative AI it does a little bit more for you. It summarizes things for you. It gives you perspectives. Now you can do text to image and create images for you. Right? It generates, as well as generative AI. So where do you think we think generative AI value will accrue? Any ideas? Actually, we don't know, but let's talk about it. I'm going to share with you where Gen AI will accrue. You all know what foundation models are? Anyone? If you don't know, it's okay. Okay, who doesn't know what foundation models are? So you can raise your hands high up and be proud of it. Yeah, that's great. It's fine. So foundation models are models that Google has trained. For example, when you use BART, it's a foundation model. But when you use Google Cloud, Palm is a foundation model. Chirp, that does speech to text, is a foundation model. Foundation models are models that are trained over a large set of data that is normally unfeasible for you to do it yourself. It's been trained over thousands and thousands and thousands of compute hours that it's impossible for any one company to do it by yourself. And these models are already so well trained that it doesn't make sense for you to build it again. Yeah, foundation models. And foundation models, mainly language models today, are made available to anyone. You can access it. The Fortune 500 can access it. So this foundation model, if everyone can access it, will it make a difference for you? If anyone can access it, how are you going to differentiate yourself with a competitor? So how you use it will be the top layer. So accessing the foundation models, it's almost like a given. It's like accessing the internet. By having access to the internet, will it make your business better? Only if you do something about it, right? Okay. So very likely the value will not accrue at the foundation model. It's just going to get more and more efficient, more and more going to be cheaper because of it's going to be commoditized. So foundation models, once again, are models that Google or OpenAI or Facebook have trained on our own because we have a global capacity. Just to give you some thoughts about this, right? To train a foundation model, the carbon footprint that it generates is like sending a rocket to the moon and back. Every model that we train, that's so much carbon that it produces. So if you're from let's say a huge MNC or a huge company in Malaysia, like Petronas want to do this, it will be almost unfeasible because there's so much resources that is needed, right? So where would value accrue then for Gen AI? So the first one is proprietary data. Applying Gen AI to, depending what companies you're from or where you're going to work in the future. Let's take a bank. You have proprietary data in a bank, right? For example, I've listed some examples like investment portfolio, bank statements, spend mix. Yeah, people like Kiwi and Arvin will probably spend more than me. Yeah, because of their earning capacity, for example. Yeah. Thanks, Kiwi. So, in a banking environment, an example, those are the proprietary data that nobody else has. That should be a competitive area to apply Gen AI. We'll show you a little bit, some of the examples in a bit, so that I can wrap up in time. I have until 2 p.m., right? Okay, good. The second area is the workflow, the company's workflow. Let's take a bank again. The workflow when you log into Maybank to you is different when you go to a bank and the ATM. So how do you apply generative AI in these workflows? That would bring the differentiator. That's where value is going to accrue for Gen AI. Because it's easy for everybody to say, oh yeah, me too. I have ChatGPT embedded in my product, or I have a BART embedded. Anybody can do it today. So what differentiators do you bring to the market? You do it today, tomorrow somebody copies you and boom, you're back at square one. Oh, cool, you have a chat interface. But what value does it bring unless you integrate it with your proprietary data, unless you integrate it with your proprietary workflows? Okay? All right. Is it too shocking for everybody? No, huh? So what we're going to introduce today is the data flywheel or data feedback loops. How do you find that feedback loop? How do you put Gen AI in the feedback loop to bring that accrued value? Now, a very quick one. This is Spotify US. It's a big customer for us. It's not available yet. What they have launched is the AI radio DJ. Now, I asked a few people who use Spotify. Somebody don't want to use Spotify anymore. Personal preference. Yeah, she's laughing now. So y'all use Spotify? Okay. No, it's okay. I thought you're making my enhancing the ambience, you know. So Spotify, normally when you first use it, you play a couple of songs and it start building a list for you. Predictive AI. Yeah. Not generative AI yet. It just look at, okay, your trend. These are probably the songs that you want. So what AI Radio DJ does now is it starts capturing the type of music you listen in the morning, in the evening, at night, and so on and so forth, and starts bringing you new content based on what they understand of you, right? And the more you use it, of course, naturally, they know more about you and they can be more prescriptive. I'm going to share with you their data flywheel in a bit. But I was joking with an audience the other day. If they saw they will never figure out my mood because every evening when there's a traffic jam, I listen to Linkin Park. When there's no traffic jam, I listen to Taylor Swift. And so they cannot figure it out. So a typical flywheel is like this, right? If you think about Spotify, how does Spotify make music? Make money? Anyone? Okay, so subscription is one way, but how else? Advertisements. What else? So the license will be their cost, right, to the music producers. So of course, the more people listen, the better the ROI would be. So you think about it, what they're trying to do here is trying to get us to listen more and more, right? To spend more time with Spotify, and how they're doing it is they're trying to be emotional with us. Okay, so if you look at it, can start anywhere. Higher listening time, the one in blue. They will get more data of our preferences. The more data that they have, they can start building more intimate recommendations. And then from there, there'll be better new music choices. So this is actually what they're doing with us in Europe right now. Okay, so the point here is for generative AI, deploy where the data feedback loops are maximized. So then, if you can, if you're the expert, AI expert, like the earlier chart, the funny chart, so many AI experts, if you're playing that role in your company, start investing time in where would the data, proprietary data be? How am I going to apply it? And how do I put it into the workflow of my customers? That's where generative AI would be maximum, all right? Okay, very quickly, I just want to share this typical chart called a layered cake. If you look at the white boxes, right at the bottom is where you build. You like to do the heavy lifting. You have a team of very strong data scientists that can actually build your own stuff, And then above that is fine-tune from the foundation models that, for example, Google makes available. Kiwi is going to touch a little bit on that later. And then right above it, customize, and then finally just use. So AIs that you just use are probably like Duet AI for Workspace. You use Google Workspace, Gmail. You start typing your email, it starts filling up potential sentences for you. That's AI. But now you can even create images on your presentations by using text. Bringing coffee in front of Twin Towers, and then it generate you an image that you can choose, right? So that's basically use. So there'll be a growing use case, guys, in every industry. So watch out for that. Don't be comfortable, I know AI, that's all. It's a changing world. The rules are going to keep on changing. The possibilities are going to change. Yeah, it's not like physics, law of physics, F equals MA, if you all remember that. And it doesn't change anymore. Yeah, physical laws don't change anymore. But IT laws, digital laws will keep on changing. So the use cases will grow. And as technical people, always remember people are the ones that make decisions. So know the personas. Who are you addressing? Who are you trying to solve problems for with AI? Who are you trying to make their lives better? Then that's the key thing, right? So there are multiple layers. And with that, I will pause here with 7 minutes to spare. Okay, so just a little bit of what generative AI will look like. And I believe the next few sessions, you're going to get deeper into the technology of it. And again, you have time. You have time to pick up this expertise in Malaysia. And also know that the window for impact is not always there. Other people learn faster, other people will pick up faster. So put yourself into this, right? AI. Okay. Any questions? Any questions at all? Must be an amazing presentation. Right? Okay. If there are no questions, I will pass it to. Thank you. Thank you so much.
Thank you, Michael. That was a very insightful one. So since you guys don't have any questions, I think it would be fair for you. Do you want to ask them questions?
Why not? Right. Okay. I shared one model earlier that talks about value accruing. What's that model called? Sorry? Oh no, foundation model. That's not the right answer. Foundation model is the AI models that we have built. Like for example, speech to text, text to speech that is readily available. Fat and thin protocol thesis. Yes, yes. Oh, okay. Yeah, I think we have run out of stock, so only one question. Oh, sorry about it. Okay, I think we're good. Thank you so much.
All right. Thank you so much. All right. Okay, so we'll move on to our next presenter, which will be talking about generative AI with Google Cloud. So I invite Kiwi to the podium. Perfect. No worries. Just give me a sec.
Sorry, got some technical challenges here. I'll be with you shortly. Right, here we go. All right, good afternoon, everyone. All right, thanks for coming here. So my name is Kiwi. Actually, I'm a customer engineer for Google Cloud, and I actually joined Google for almost 6 years already. I came from a startup background. So this is my name, Kewooi. Fun fact, right? A lot of people find it very difficult to pronounce my name. All right, Kiwi. Yeah, you got it right, correct. I'll give you some socks later. All right. So Kiwi is my real name. All right, but a lot of people find it very difficult to pronounce my name. So for all my avatar, right, I always use this. Okay. You know what? Everyone know what is this, right? It's a slice of kiwi fruit. So everyone should be understandable, make it easy for people to understand, right? Yet, when I go to meetings, right, I remember that there was one time when people tell me, "Oh, very nice picture of donut. Nice donut." Yeah, right. So that's why AI is very, very important. All right. Welcome. All right. As I mentioned, right, I actually came from a startup background as well. The company I was working for actually got acquired by Google 6 years ago. So that's I have been a customer engineer. Actually, joined as a software developer. Then fun fact is that before I joined Google, I actually used to attend DevFest a lot. So it's good to see the same crowd here again. Welcome back here. All right. Today I am going to first talk about. Let's chat about ChatGPT. All right. Yes, you are in fact you are here in the right room. This is not a Microsoft room, or this is not an OpenAI room. We want to talk about these competitors, right? But we need to talk about ChatGPT for a while before we start anything with GPT, because it's all everything started, right? So some fun fact, all right? Socks. I'll give you socks as well. ChatGPT, right? What does the T stand for? Brain, not really. Transformer, yes. Transformer socks for you, bro. Okay, pass it. All right. So the T from the ChatGPT actually stands for transformer. And fun fact is that transformer is actually something that was actually invented by Google. not too like near ago. It's actually back in 2017. So a bunch of Google scholars actually published a paper called Attention is All You Need. That's right, right? When I put it in my here, right? You can see that here, the tagline here is attention is all you need. So basically, y'all started from there. Attention is all you need. This is actually the paper that we published back in 2017, talk about transformer, talk about how large language model can work. And then back in 2023, actually 2022, it's all starting with ChatGPT. That's all, everything started from there. Okay. In fact, right, Google is the pioneer in AI, not only in recent years. Back in 2015, we already have this DeepMind AlphaGo. It defeats the Go champion. This is where the AI stuff start to blossom from that time onwards. Transform is 2017, and of course very recently everyone was talking about BART as well. This is what some of the recent inventions from Google. All right, then not sure whether you pick up this news back in 2022 or not. So there was like a news going around and say that hey, there was actually an engineer and ex-engineer now from Google. They say that hey, Google actually had a very secret thing called Lambda, and it's actually sentient. Right, my English is not that good, but I checked before I come here that it's called sentient. That means like it's someone that think of it like a machine, like they can have like feelings, can feel. Anyone remember this news? Yeah, and that is actually before ChatGPT, if you recall. Before ChatGPT was even a very popular thing. Okay, we had one shot at that time that to make it very, very big. All right, we could have like launched something and say like, hey, everyone just use Lambda. Yeah, you got me. Lambda is actually something very cool that you can use it and you can make it like a machine, like a human-like machine. But we didn't, because at the time, right, the thing is far from perfect. Far from perfect, so we could not actually release the thing and then just everyone use it, because responsible AI has been one of a very, very foundational kind of commitment to the community. We can just simply just launch as is. Okay. In fact, right, if you could even go back further with the AI train, right, we didn't even start in like 2022 or 2017 that I put in my previous slide. Back in November 2017, we were already like the AI first company already. We already like, Sunda, our CEO, right? I already say that now we actually pivot into a everything also AI first kind of company. Right. Now, some quiz here, okay? You all can recognize this. I know there is a room of developers and software engineers here, right? You all can recognize the icon here without me saying this, what they are. On the left, Android, yep. Center, Google search. What about on the right? Google Maps, all right. What do they have in common? Google, yeah. Yeah, this is from Google. I think we're looking for a little bit deeper than that. Powered AI, yeah. Firebase, I'm not sure about that one, but I cannot say also if it's Firebase. Not sure about that one. Okay, so the common of these three, I'm going to review the answer, right? So the common thing about these three is that we were not the first when we launched these products. Android was not the market leader. Google search, everyone was using Yahoo back then. Google Maps, MapQuest, remember anyone? Those are, I'm not that old. All right. So one thing we have in common with these three products, right? They were not the market leader. Very, very far away from the market leader. All right. But then over time, we did it very, very well. That's how you actually get the users and then they become the market leader. Okay. So anyone know who this is, right? Sunda Pichai is our CEO. All right. So in one of the messages that is actually put on CNBC here is that the message that he told us is that some of our most successful products were not first to market. That's a fact. That's simply a fact. Okay, they gain momentum because they solve important user needs and they were built on deep technical insights. If you recall, last year or even early this year, there was a lot of news talking about, hey, Google is losing the AI market leaders. Google is like code red and everything, right? It's like we were panicking. But the truth is, all right, we really want to like make the product like very reliable. Then only we launch it to the public. And then today I'm speaking to a a room of developers, right? I want to share with you what you can do with Google. And more importantly, you want to know that this is Sundar Pichai, right? The AI is literally in his name. See the Pichai. Okay. Hence, AI is so important for Google. This is the real reason, all right? The whatever I said is second. Okay, just kidding, all right? But yeah, it's just to show you how important this is to us. Okay. So this is okay. Everything go back to our philosophy. Okay. I'm not sure if you have used Google long enough or heard of Google long enough, have heard of something called "Don't Be Evil." Things like that. There's some notes over there as well, right? So many years ago, right? Actually, we published something called our philosophy. About 10 things that we know to be true. Okay. And number one is that focus on the user, and then the rest will follow. Okay. Today, this still holds true. All right. This I put in this the publicly referenceable link. Actually, if you go to google.com/philosophy, you see all these 10 things that we said, we will keep true to those philosophy values that we hold. Okay. That's why this is not a mistake. Actually, go back to this slide. All right. This is the same slide that I showed you just now about our advancement and our investment right from the beginning in AI. All right. The one that I want to get your attention to is, let me just cross this one. Okay, is the responsible AI piece at the bottom here. Okay, so we have like 3,000 over researchers, and we have like 7,000 or more than 7,000 publications on AI alone. All right, so our guiding principle is that it's responsible AI. Okay, because AI is, it could be something that can be something harmful. All right, if you think about it, today, not sure whether you read about the news that AI use AI to actually target like civilians, some destructions. So these are the things that we do not want to do. So that's why we have very high standards that we want to meet before we actually release the products to the masses. Okay, and then thanks to that, now I just want you to know that AI is one area that Google really put a lot of emphasis on, starting from this year. Like especially this year, like go-to-market. So this is one of his report. 70% of generative AI staff actually rely on Google Cloud for the AI capabilities, right? Because we are talking about Google I/O extended here, right? It's good to have a very small recap about Google, the message that our CEO wants to tell everyone from the Google I/O that just happened in 2023. Okay, this is a recap.
AI, generative AI, AI is AI. It uses AI to bring AI.
All right, that's all. Thank you. Bye, everyone. No, it's not done yet. Okay. Making fun of CEO is not a very good career moving strategy. But I was actually looking for an actual video of like summarizing the Google I/O. Actually, Google I/O, you think about that, Gen AI and AI was really the main focus that we had. Okay, I was looking for a good video, and then someone put this here. I thought it's true as well. Okay, I'm not making fun. I'm not like making it like saying wrong or fake stuff. This is really in the keynote that our CEO had shared with the rest of the world, where the focus of Google is going to be from the Google I/O. By the way, if you love Google I/O, did you know that we have another big event coming next week? No one knows? Yes, Google Cloud Next. Yeah, Google Cloud Next is happening next week, right? Next week. Yeah, the name is literally called Google Cloud Next. I'm seizing the opportunity because it's happening next week, so I put through a pun here. Okay. Look like it doesn't work.
AI.
So with all these like AI stuff, like everyone, there's something that my teachers taught me. If something you want to invest in, right? If your parents are talking or your friends are talking about it, probably it's too late already. Now AI stuff is like, if you think about it, it's like it's in everyone's mouth. In all the papers that you see, all the things that even you don't touch AI will come to your face as well. So is this another hype cycle? All right, let's study this together. Okay. Now, number of years for a certain product to acquire 50 million users. I just want to put it up here. right? It took radio 38 years to achieve 50 million users, TV 13. And Gen AI here, you can see there's a stark difference. 13 years and 0.08 years. This is a very, very short moment of time for AI, for Gen AI to reach 50 million active users. This is a huge, huge progress. Okay, but no matter how Gen AI is good, it still cannot beat one thing. Anyone want to take a guess? What is this? 0.05, even faster than Gen AI. No, I just want to give you a hint. This happened in, I think, 2018, 19. Oh, no, before that, 16, something like that. There's some crazy stuff going on here. I'm not sure whether any one of you remember. Not too far ago, not too long ago. Yes, exactly. Pokemon Go. It took Pokemon Go just 19 days to reach 50 million users. Let me remind you of this. Remember this? Like, you know, a bunch of people going crazy. Hey, there's a Pikachu over here. All right. But, you know, it is an impressive feat, but Gen AI is important as well. And then, of course, Pokemon Go has to be put on a very stable, for this kind of user, it has to be on a very solid platform, right? Guess where it was hosted? Yeah, so Pikachu here said, I'm Google Cloud as well. Okay, so it's for me to like, you know, sideway into pitch Google Cloud a little bit. Okay, all right. So putting these jokes aside, okay, so is this like another hype? Is this something that, you know, just like, you know, some people say that, hey, blockchain, you know, Web3 is a hype. Whether or not it's too soon to tell. But what about the Gen AI? Is it just another hype that, you know, this, or maybe it will die down after 2 years, right? So I just want to share with you, this is where machine has come along, all right? Machine has recently exceeded human performance. You can see from the grids here, right? We start from the baseline at 0. Anything below 0, that means human does it better. Anything above that, that means human does it worse. Machine does it better. And then this is the timeline. Okay, from handwriting recognition, you know, back in the 2017, 18, 14, maybe you could have recognized it very well already. Okay, the one thing that, you know, we would like to share with you is that for language understanding, it's like a sudden boom back in like 2017 from Transformer, era of Transformer, and all these are related invention from there. All right, so right now, machine can really understand language very, very well, better than human. Okay, hence that you have something called LLM, large language model. You can actually link a lot of things, all the languages together, and then it actually generates stuff on our demand. And I said just now, whether we like it or not, AI will come to you, right? Anyone know what is this? Google Trends, right? Thanks. So Google Trends is actually another very, very cool product that we have as well. It's free. Just go in googletrends.google.com or google.com/trends, right? And then you can put in some search stuff. Okay. So this is the worldwide interest over time for people that search for AI. Okay. And then thanks to ChatGPT, thanks to the invention of AI and our investment into AI, right? This thing has like, you know, peaked right now. Okay. Now is actually the best time to be in AI. Yeah. So we are in the AI-driven revolutions. Of course, 1784, steam power, it changed everything, changed the industry. It's the IR one. And then, of course, we know electricity changed everything, and then IT changed everything. In IT itself, then we'll talk into like, hey, mobile will change everything again. So all these are true. Today is the AI in this landscape, right? We think that this actually could drive the next X number of years. I'm not sure how many more years that, but this is something definitely the main engine is driving us forward. Okay. So the path to generative language model, all right? So you all are developers. On the left here, you can tell that, oh, I noticed a JSON over there. Okay. So this is a thing from traditional programming. I'm sure that, you know, one of the first programming courses that you take about OOP, right, is that if your cat has this, I want to inherit it from an animal. So how you actually do this polymorphism. Okay, so I purposely choose this because I know that I'm talking to a bunch of engineers here. So Traditional programming, you define what a cat is, type animal, legs for, this is all this, right? Then the second one, we have this AI ML. Remember a few years ago, everyone used to have a lot of AI ML as well. So AI ML is that, you let it to this traditional AI, right? Make it to say that, okay, this is a bunch of cats, this is a bunch of dogs, go and learn. And then after that, you take fresh pictures of cat that the machine has just seen before and ask, is it a cat? Yes. Is it a dog? No. Right? Then now we are here in generative AI, is that, you throw a bunch of books to the machine and say, go and read this. This is how you define a cat. So you understand a cat a lot better, a lot. And then you can ask this question, is it a cat? I want to see a cat, sunbathing in front of the beach. Do it for me. So this is what generative AI can do for you. Okay. Oh, by the way, I should have said this. If you have any questions, please feel free to just raise your hand and let me know anytime. Okay? Let's make it as casual as possible. So yeah. So since we talk about Gen AI, right? We want to know what kind of new opportunity Gen AI can bring to us. All of you, right? Like in a way, like represent your company, like doing your day-to-day work, right? You want to know that, hey, what are the things? What is it for me to actually bring some productivity? What can we do with Gen AI stuff, right? So it's for different personas, right? Just listed down some of this here, like complex data, intuitively accessible, and you can ask questions. Like for example, I'll just give one example. Just imagine that now you can actually throw a bunch of all your company documents, everything, throw into that. All right. I'll just give one example. Is that our Google's, because it's a public listed company, so we will throw all our financial documents into a repository, right? And then use Gen AI to train, and then you can ask questions. All right. In which year did Google say invest more than 10 billion in say sustainability? All right. So Gen AI, right? With a Gen App Builder, right? With this product called Enterprise Search, we'll be able to understand whatever actually it learns from there, and it can bring the context, understand the questions, and then show you the answer with citations. I'll show you a bit on that after this as well. Okay, and then this the Spotify and the app that Michael touched on just now. Just imagine that instead of going to just your bank, Maybank to you, just click on things, right? You can ask questions that, hey, can I borrow 5,000 next month? I'm in need of money. All right. So imagine that your app can actually understand all these the briefs about you, the portfolio about you, everything, and then it can actually come and tell you, yes, we'll be able to provide a personal loan of 5,000 to you. Or would you like to click on this to understand more? Really, this is all things that you can actually interact with your app now. So this is the other use cases that we have just put it here for examples. You can, like, for example, images. Instead of like, because you used to, like, if let's say you want some images, you need to go to a stock photo services to get the stock photo. Now you can actually just prompt and say that, hey, I want this, the picture of a cat, and then you'll be able to do that for you as well. Okay. So what are Google's offerings? All right, there's a lot of sick. And then, in fact, has anyone used any of the Gen AI product that Google has so far? Yeah, nice, thanks. Okay. Okay. So one big difference that we position, right? Because for the consumers and the enterprise, they are different. Okay. So for consumers, has anyone used BART before? Yes, everyone has used BART, right? Yes. Okay. So BART is nice, handy. All right. You can actually use it for, hey, I want to plan a three-day trip to Tokyo. Try to like prompt that and say that, hey, I want to have a 10-day trip to Japan, and then I want to go to Tokyo, Osaka, and Kyoto. All right. Just give it a challenge. All right. If you actually give you not like one day in Tokyo, the second day in Osaka, the third day in Kyoto, that doesn't make sense for you to like travel like back and forth. You actually zoom in like 3 days in Tokyo first, then you take Shinkansen to Osaka, then you take the local train to Kyoto. So you give it a challenge there. Okay, so that's for the consumer side, and then for the enterprise side, right? I'm not sure whether you read recently about a company we shall not name here, like use ChatGPT, but then they put in some sensitive data, company data there. All right. And then it got leaked out and then it got banned. Okay, so because you're using something that is not meant for enterprise, it's planning a trip to Japan is one thing, and then throwing all a company secret into that is another thing. All right, so we cater for both. All right, for consumers, you can use Bar and Baker Suite. And then for the enterprise, for your work, day-to-day work, right, you can actually use Peatix AI and Duet AI, which I will go through very quickly in the interest of time. So this is actually this underlying foundation models. Just now, Michael touched on. All right, we have Palm 2, Cody, and Imagen. So Cody is the model that we have for our code generation. Has anyone used this GitHub Copilot? Is it nice? Very quite nice, right? Okay, so watch out how you're coming. Okay, so Cody is the model that is meant for development. All right, and then Palm 2 is the generic one for all these the AI the Gen AI products that we use. And Imagen is for actually image generations. Okay, so I will go through this very quickly. So this is about this the business side of stuff, right? Depending on what kind of personas you have. If let's say you are business users, what you want to do is that you do not want to do any programming. Right? There's a lot of word about no code, low code. All right. So let's say you're a business user, you do not want to actually write out your Visual Studio Code and start writing Python, right? It's not what you want to do. So you want the AI to come to you. You want it to be very easy. Just open up a new document, just right there. I want to write an interview letter to thank someone or whatever. All right. You actually generate the whole thing for you by just prompting it. All right. This is for the business users. Okay. And then for the developers, we have this Gen AI app builder. It's a mouthful. In here, we have enterprise search, which I briefly talked about just now, and then the foundation models and the conversation AI. This is the one that I mentioned just now. You can actually start talking to your app. Okay, and then Vertex AI is our umbrella AI platform for everything that is AI related. And then on top of that, you have these foundation models. If let's say you want something to do with text, chat, code, everything in there is in there already. Okay, if let's say you're AI practitioners, you're ready to actually write some codes there. Okay, so Duet AI for Google Workspace Enterprise. I just want to know, does anyone use Workspace here? Google Workspace. Yeah. Okay. So this is in a way Microsoft Office competitors. Okay. So the Docs, Gmail, the spreadsheet. If you're coming from MS Role, is the PowerPoint, Excel, Word. This. So in here, right? In Google Workspace, this is the one that I just mentioned. Start a new document. Help me write a proposal, to do some investment in here and here. All right. Then you come up with a proposal. Boom. Have this. Just verify and then send. Okay. And then for cloud developer, can I just check, does anyone here use GCP already, Google Cloud Platform? AWS? Oh, you still Azure? Oh, okay. It's a very good mix of these three. Okay. So Duet AI in Google Cloud is, just think of it, right? When you go to the console, you can ask questions like, I want to tell me what kind of SQL instances can I scale down. So of course, you as a practitioner, you can go and find the question yourself. All right. But now we actually give you kind of a Clippy, if you remember last time the Microsoft Clippy thing, that you can actually ask questions and then give you to the thing. More than you missed the Clippy. So cute. I hope that we're doing it slightly better than Clippy, not as annoying. Okay. Not annoying. Yeah. So not okay. So and then you can actually say that, okay, I remember there's a gcloud command. By the way, gcloud command is the CLI command that we use to interface with Google Cloud. So I remember that there's a gcloud command to actually spin out an instance in, say, Singapore with 4 CPU and 16 gig of RAM. So instead of Googling this yourself, you can actually ask this question, and then we actually tell you that, oh, thanks, this is how you would run the gcloud, and then you just copy paste, right? And then of course the Copilot equivalent that I mentioned, I will touch about that as well. So Gen App Builder, I mentioned this just now. Let me go through this. We can have conversational AI. Okay, now that the the questions that you can ask on Maybank to you, not to pinpoint a Maybank to you, right? Let's say any banking app, right? You can actually ask questions, or this is actually a bike rental. Okay, you can actually ask the question, oh, I need a bike that is so I can pack and put on, I want to go take a flight to somewhere. All right. Then it should be smart enough to know that, oh, for this to be a checking luggage, it has to be less than 23 kg. It has to be able to check into a 28-inch bag, whatever. All right. Then it will give you the suggestion. And then you can ask question. This is nice. But what does it look in front of the beach? Because I'm going to run some triathlon in the beach. How does it look like? Then it can actually show you general image with that the bike that you want to the bicycle you want to buy in front of whatever you say in front of the beach. If I look cool on that, that is what could happen with GenApp Builder. Right. So enterprise search, just think of it like you can actually bring the power of Google into your organizations. All right, you can get it to actually do website search, do document search. So for document search is unstructured data. Just imagine that you put in the repository. If let's say you're from AWS world, is the S3. If you're from the Google Cloud world, is the GCS, and Azure, I think it's called block storage. So just throw all the images, your documents, PDF, HTML, throw into the repository, and then train from there. And then you can ask questions. I want to know which customer, let's say you are from a legal firm, right? I want to find an example of who won this case. And then you can edit out for you. From this PDF, there's a A versus B, and the verdict is B lost. Why? Now it's possible. Okay. So Vertex AI, running out of time. So Vertex AI is, as I said, is an umbrella technology for you to actually do everything AI. So if let's say you're an AI practitioner, you want to get your hand dirty, you want to do programming, this is where you want to go to, right? Take the foundation model and then do some tuning, and then you can start inferencing from there. Okay. Let me just skip that. Okay, Gen AI Studio is for you to actually try out a model, try out a foundation model. It give you like a playground for you to actually put some prompting in there, and then you can actually get some response. Okay, so I was surprised myself as well. I didn't know that actually we have so many things in GA already. I used to think that we have a lot of things not in GA yet. So this is some of the foundation models that you already can try out today. For your text, for chat, text to image. Text for image is you have to be in a wait list. Some of the things, chirp for speech to text, they're all in GA already. So if today you still don't have a Google Cloud account, so the good news is that you can get $300 worth of credit for free. Sign up, just go in there, $300 for free for you to actually go there and play around with this. Very easy. If let's say you like command line, from command line you can just send in the curl command, put in your API key, and then there's a response for you already. Okay. Okay, so text to image, we have been talking this a lot. Coming soon, you'll be able to actually throw in this, what is this, and then generate image based on that as well, or prompting. This is speech to text. From there, we can understand like 98% accuracy on English, so that you can actually throw in a text, the speech, it will actually very correctly convert everything to text. Model Garden is where you can go and see a lot of existing ready models, either from Google or from third party. We're going to have everything in the marketplace for you to actually use that, so that it's for your, let's say you have a specific thing, for example, medical or law firm. All right, just to throw some examples. This is where you can find the model ready for your things. Okay. Okay. One thing that I think is very important here is that privacy. All right. I just want to show you that because all these are enterprise ready. One thing that you might have like heard wrongly, or things like, hey, Google might use my data to actually train the model so that it can sell the things. I want to just mention this again and again. No, your data means your data. Google will never use your data for the model training, because when it comes to Vertex AI, your data means your data. That's all. Nothing more than that. Okay, so don't worry about, hey, what about Google use my things to go and like make your doc better, so that when you type something, you can actually finish the sentence. No, not going to happen. All right? Yes, please. Yeah, belongs to you. Where does it get? Okay, good question. So the data that Bart is on the consumer side. Bart will actually search scrap on the web, and then in the public domain, of course, we will search that. But if the thing is searchable, right, then I believe that you come out in the search as well. But of course, it will tell you that where the citation is, where it comes from. Yeah. Thanks. So you control data, not Google. All right. Just want to just bring it out here. We have this assurance that your data is safe with us, so that you can actually feel like at ease to actually deploy the models for your business use. Well, this is the one that I said I should not mention. It is because you're using the wrong product for the wrong purpose. Okay. So with Vertex AI and we think with Google Cloud, right, this thing you can be assured that this thing would happen. Okay. So what does it mean for me? So AI is, as I mentioned, everyone knows about AI, right? And then we might think that, oh, snap, AI is going to take our job already. My job is going to be at risk because AI will take over. Okay. This is true, right? But then at the same time, okay, there's also a bunch of new jobs that's coming. All right. Have you all heard of something called prompt engineering? Yes, right? 335,000 a year, prompt engineering, just type. Okay, so our 335 US dollars, not ringgit Malaysia. So it's over $1 million just by writing the right prompt. Okay, so this is just want to share with you. We very recently come out a blog about how you actually can do prompt engineering better. Number one is that you have to know the model's strengths and weaknesses. Of course, if let's say the model is about blueberry muffin, don't ask about strawberry muffin. It won't be able to do it for you. Okay. Number two is be as specific as possible. Just say that, okay, I want to prepare a recipe of, instead of asking, oh, give me a recipe of blueberry muffin. Just say that, oh, I'm throwing a party, I want to put in a 50 muffin. Can you do it for me? Be as specific as possible. Utilize contextual prompt. Say that, hey, I have some guest that is vegan, right? Can you do this? I have 5 guests is vegan. Then, this is how you actually construct your prompt as well. Right, AI model is an example. Hey, I used to like this thing that is from this chef, about this muffin. I like it so much. Can you do something similar to that? This is how you do the prompt engineering. And then explain the prompt and personas. Give it some examples. Give it some personas. Hey, I'm a grandmother. My grandmother make very, very good muffin. How do I explain this to my grandson? Things like that. And then chain of thought. Starting from here, I want this, and then I want starting from the muffin, and then I say that with my guest, so that you can actually do a multiple stage for you to come out to a better response. Okay. We have a free something called Google Cloud Use Boost, mouthful again. Right. This is actually something used to call from GCP. I heard something GCP. Yeah. So this is we have 10 courses on Gen AI, and it's for free. All right. Just take a pause here so that you can capture this. Otherwise, I will share this after this as well. So it is free. Go in there, whether this is from the AI practitioner or whether you are the C-suite, you want to know what is Gen AI. Right. It's 10 courses for free, so they can go there and understand more about this. Right. I will share the link after this. Sorry about that. Okay. And then Google Cloud Next is next week. This is the one I mentioned. If you like Google I/O, everything that is Google Cloud related will be announced in Google Cloud Next. And generative AI is going to be something front and center. We're going to announce some very, very exciting products as well. Some exciting product will go live as well. Okay. Now, just one last thing. Sorry, Arvin. Just one last thing. Okay. So because it's a bunch of developers here as well, right? I just want to share one more thing. I'm speaking in fact, one more thing. Does it ring any bell? Does it remind you anyone? Of course, he does it better than me, lah. And okay. So one more thing that I want to share with everyone is that if I share with you this, right? What does it remind you of? Okay. VS Code, right? Is that VS Code, right? Okay, so VS Code, everyone loves VS Code, right? Okay, so I just want to share with you a project called IDX from Google. It's based on VS Code. It's based on open source of VS Code with some Google goodness in there. All right, it looks like this. Built on VS Code, comes with Duet AI, designed for collaborations, live review, and very deep Google integrations. And today, you can already join the waitlist. Okay, it's launching soon. Okay, so today you can join the waitlist. Please sign up today. In fact, you cannot scan this. It's okay. It's idx.dev. Very simple. All right. I wanted to like give this because I know that a lot of them love programming, and today, right, everyone use VS Code, and yeah. Okay, that's end of my slide. Sorry, I take longer than it's supposed to. But any questions before I go? No? Oh, sorry. Sorry, Arvin. Google? Mm. So the question is about if you want to find out more about the transformer, how the model works, right? So we actually put it in Google Scholar. It's actually open source. You can actually go in there and download the whole paper. If let's say you are into that very research paper. Otherwise, right, I have seen many very good, which I don't understand, videos on YouTube, because I always go YouTube. For sure, someone so much smarter than me will understand what is this. So that would how I would usually go. Yeah. Hope I answer your questions. Yeah. Can. Google Cloud next. So the question is that this one. This is Google Cloud next. All right. Thank you so much for your time. I hope that I've shared something useful for you, and thanks for the opportunity to learn from you as well. All right. Thank you. Enjoy it.
Thank you, Kiwi. That was really insightful and so exciting to see Google stepping up to do their own version of VS Code. I was honestly impressed with the collaboration part because that's something I've been wanting for so long, and it's just fantastic. So our next speaker is, Arvind, and he will talk a little bit more about image data classifications with BigQuery ML. So I invite Arvind to the floor.
Hello everyone, good afternoon. My name is Arvind. I'm a lead solution consultant, data analytics, Google Malaysia. This is my 7th month, and I'm seriously, warm, kind of overwhelmed with a lot of innovative things going on in the Google. TV already shared a lot of things, and still I see that people are still trying to digest a lot of contents. So obviously, I think last a couple of months we see that generative AI is everybody is trying to learn, everybody is trying to understand that the bigger part everybody is trying to solve is that what are the use cases that generative AI can help. Technically, people are understanding, they are still doing research on the generative AI, but the important part is use cases, right? Today, definitely my topic is in image classification, but before touching to the lab, just a disclaimer, in my session, few slides, but more, hands-on lab technical. So today, before jumping into detail of image classification, I'm going to talk about what is AI Lakehouse and why it is important. So if you look at that, before Gen AI, we all were focusing on data analytics. We all were spending a lot of time in building the data warehouse, right? Now the time has came where we have to think about, journey of data to AI. How can we make sure that data is not just AI data, but data is very crucial and it is a fuel for AI. If data is not clean, if data quality is not good, then you will not be able to get the output of the expected output through the generative AI. So concept of the AI Lakehouse is mostly unifying the structured data and unstructured data, right? That's the point we're going to talk about. Now, how Google Data Cloud Platform is going to help. So So my role is, customer facing role. On day-to-day basis, I go and meet the customer, try to understand their problem statement, and we try to understand, we try to, design the solution and also give some, advice from the operational excellency point of view. So most of the customers, the feedback and then the question and the kind of, the sharing that they, and the kind of, what we're hearing from the customer is that, okay, how, we can bring more and more new customer. If I'm an e-commerce platform, how can we bring new customers? How can we increase our sales by hyper personalized contents, right? And they also talk about if it is really, a startup kind of company, they are thinking about that. How can I improve my developer productivity? Can I use kind of, code assistance? And also the way they are engaging with their customers. They are thinking that how we intelligently, how we can, engage with those customers. And also, definitely, so far we have all collected and got all decision by using the data, which is structured mostly. But now the thing is how we can leverage the unstructured data. If you talk about oil and gas company, right? Those kind of customers. Where on the engineering side, right? When they're upstream side or when the engineers are drawing the diagrams, all those documents are there in the PDF files. And those are the unstructured data. Are they able to leverage as of now? Maybe, I would not say zero, maybe in less in terms of percentage. So there are a lot of information, lot of data is there in PDF format, maybe in video form, audio form, maybe in text form, right? So how we can leverage those data as well? Because through a data warehouse, you can, generally take the tables, you can fire the query, and maybe you can do the prediction and share the insight through the, some visualization tool. So we as a BigQuery, in the Google BigQuery tool, how that can help to unify the structured and unstructured data. So Google's data and AI cloud, if you look at the three main important pillar, AI lakehouse, we're going to talk about that. And which is, because when you're trying to develop as a technical, as a data professional, when you're trying to develop the AI lakehouse, definitely, the developer mindset. Somebody like the Python, somebody like the SQL, somebody like the Go language. So the data platform that we are trying to, offer to make sure that most of the personas, different user personas and different types of language, different compute engine. And also it is not necessary that data is always at one place. What Google believes, Google fully empathize the, customer situation, which means that wherever your data is fine, you don't need to bring your data, from all different places and put into the, Google Cloud storage. So Google data cloud strategy is that if your data is in the AWS, if your data is in Azure, it's okay. There are way we can help them to bring the data into the Google Cloud. Not necessary that you need to move all the data from AWS to the BigQuery. I will show you how. And now I want to ask one question to you. If you, how many are using BigQuery first of all? 2, 3, 4. Okay. Okay. So my question is that recent announcement related to BigQuery, which recently, which format is supported by BigQuery? The latest, announcement. Anyone? Okay. Don't worry. So mostly what's Google's approach is that how we can contribute in the open source community and how we can leverage the open source format. So recently, if you heard about the announcement, is now Google BigQuery also support the Apache Iceberg. Google BigQuery also support the Delta format, right? So there are continuously innovations going on the BigQuery to make sure that it target the different personas and also giving the platform which can be leveraged by multiple different data professional. Apart from AI lakehouse, the important thing is another important thing is generative AI. So BigQuery it will help you to unify the structured data, unstructured data. But where is the foundation model, right? So I'm going to quickly show you that where KV already mentioned, the foundation models. I'm going to show you what are those foundation models and how can you leverage those foundation model quickly. So obviously, this diagram talk about, you have a data warehouse. Maybe your data warehouse is maybe a Redshift or maybe, Azure Synapse. I'm coming from, I'm ex Microsoft, so I'm coming from Microsoft background. And before Microsoft, I was end customer for AWS as well. So generally, customer have the data either in the AWS S3 or maybe in the Azure Blob Storage, either in Synapse or maybe in Redshift. On one side, they have data in a Google BigQuery, right? So most of the customers are facing the challenges of how they can do the unify, how they can join those data, and those data could be structured, those data could be unstructured data. So BigQuery help them. So we're gonna have the lab, and through that lab, I'm gonna show that how you can process the unstructured data, how you can do the prediction on the unstructured data. But in the BigQuery, what is the particular features which is helping us to achieve that? We all know about the BigQuery table. That is native table, BigQuery native table. Anyone heard about the Big Lake table? So Big Lake table is really a major contributor to achieve the AI lakehouse. Because what it is saying that, so basically you all heard about the external table, right? So external table, which means that your data is not in the Google BigQuery, your data is somewhere else, and you create an external table, and then you can fire the query on the external table. So Big Lake is a type of external table, but not exactly external table. Because when you talk about external table in the other data warehouse, you missing the ACID operations, right? And you missing the security from data security point of view, row level security, column level security. So those kind of features you miss in the normal external table. But in the Big Lake external table, Big Lake table, it is not only supporting the structured table, structured data, but unstructured data. When you are trying to leverage the unstructured data, which is in your lake house, which is in your data lake, that is called object table. So you have your images, which is somewhere in the storage, could be a AWS 3. Again, I keep emphasizing on the multi-cloud strategy, because Google completely believe in the multi-cloud strategy. Because Google is saying that, as I mentioned earlier, Google is always say that wherever your data is, we will help you. And that's how we develop the product. That's how we innovate the features, by keeping this thing in the mind, the multi-cloud. So Big Lake object table, if your data in a Google storage or in AWS S3, you create an object table, you create which is a kind of Big Lake object table. And after that, the way you play with that table, the way you fire the query, the way you join this Big Lake object table with other structure table, BigQuery native table, you will not realize that you are playing with external table. You will feel like it is same like BigQuery native table. So one lab I'm gonna do is like an image classification. So how many people do the yoga here? 4. Okay, great. So I'm gonna take few pictures of yoga, different poses, and then we do the classification. Because we know that because yesterday day and day before yesterday we had a Google offsite, and we went for yoga session also. So I can still remember this pose, warrior 2, warrior 1, warrior 3, right? So one of the we do the classification of the one of the pose. And how we gonna do that, right? The flow is like, you have all the images, all the unstructured data, which is images, right? You keep all images in a storage table, not storage table, basically Google Cloud Storage. You keep all the images in a Google Cloud Storage, and then you create a Big Lake object table. So while creating Big Lake object table, you need to give a path where your images are. And once your images are there, you create a table, then you try to create a model, machine learning model, right? Now, Michael was asking the difference between GenAI and AI. right? So that's here you will realize that. So when you're creating a model, if you go with the traditional AI approach, so basically which means that you use either TensorFlow model which is already trained, and you just use that file of that model. That's one way. In create model, if you want to leverage the generative AI foundation model, that also you can do it. So that that SQL code I will show you how you can do in both the way. You have your own model where you have your own model file, or you want to train, you want to have a custom model, you can do the training of that model, you can register that model, and then you can come back to the step 2 and start using that model. So once you have your data in the object table, once your model is there, after that, next step is prediction. You're going to predict whether this particular image belongs to the pose warrior 2 or any other pose, right? So once you identify the particular pose of the yoga, then somewhere you just imagine that you have structured data also somewhere in the data warehouse. And that table is doing what? That table is telling you the benefit of each pose, right? If you're warrior 2, these are the benefit of warrior 2. And these are the dietary that you should follow. That kind of structured data. So you get an image, you predict that image, and after that you identify that image belongs to the warrior 2 pose. Then you link with the particular rows of the tables, which the benefits which belongs to the warrior 2. So that's how you do the joining of structured and unstructured data. So this is a sample code, how it looks like. So basically you simply go and create an external table. You're not mentioning anything. What you're giving, you're just simply giving the path of GS, Google Cloud Storage. You give the path of Google Cloud Storage where you have already put all the images, and then you have a with connection. So if you're already familiar with the cloud, in the cloud, when one service talks to the another service, they use a service account, right? So with connection is nothing but a service account that you use to establish the connection between BigQuery and Google Cloud Storage. And on the right hand side, you can see this is how the data looks like. And then second step, you create a replace model simply, right? You just give the path of the model. If you already have the model somewhere that you already trained, you download it from the TensorFlow site. You just put the path of the model, and then you mention that model type is TensorFlow, and simply go and create a replace model. Everything you are doing in a SQL, you are not writing Python code here. And you are not writing you're not referring any Jupyter Hub notebook. 2-3 lines of SQL code. For initial first step, you create an external table. The second step, you create a model. And third step, you see, simply you use the ml.predict, give the model name, which you created in a previous step, and then you start the prediction of that image. Right? So this is in the model path. Here you use the model which you already trained, right? The next screen, in the next slide, which I'm going to show you, how you can use the large language model also within the BigQuery. Right? So within the BigQuery, again, you are writing a SQL code. The function that you are using to leverage the large language model in the BigQuery is ml.generate text. What you are asking here, give the country name of the city. You provide the city. The city may be somewhere in your BigQuery table, or maybe you can hard code that city, and you're asking give the country name of the city. So that request goes to foundation model of Vertex AI. Again, I don't use the name Vertex AI. It might confuse you. Later, I will show you what is the Vertex AI tool. The query goes to the generative AI large language model, and then it simply give you the results. Now you may ask that what you are giving as part of the query, what are the things that you are giving, right? If you're coming from data science background, you know that when you are trying to do the inferencing or prediction, then you are giving some kind of input parameter to get that more accurate results. Here we mentioned generative AI, people thinking that generative AI will take the jobs and people will lose job. Prompt engineering, the more and more prompt engineering jobs are coming, right? So I always say that power comes with the responsibility. Generative AI is giving us lot of it makes our life easy. Whether you're a developer or a business user, it makes your life easy. So difference between generative AI and the old AI, if you look at that, I would not say old AI, it's still AI. So you had a dedicated model for every AI use cases for text, for speech. But then in generative AI, you have large language model, Palm 2, which is doing a lot of different types of work for you. But what you need to do, what's your responsibility? You have to make sure that you design the prompt. The prompt engineering is your responsibility. What kind of output that you are expecting from generative AI, it completely depends on the how you do the prompt engineering, right? So that also you can do as part of this query, but here it is not included, but still you can do. Generally, as a data scientist, what code you are writing on your Python notebook or Jupyter Hub notebook, those kind of things you can do in a SQL, in the BigQuery, using the BQML features. One, if I take an example of sentiment analysis, right? Before the generative AI, if you do not use a generative AI large language model in the BigQuery, you simply go with your own, traditional way, and you do the sentiment analysis. This is how you get the results, right? You always get the, magnitude, type, score, this kind of numeric value you get. But if you use the large language model in your query, yeah, this is how you get the results. Sentiment, not a numeric value. You directly get, the sentiments are neutrals, negative, positive. That's how you get the results through the large language model. So BigQuery ML. So BigQML is very, very popular, and really a lot of users like it because a lot of data engineers, data science, definitely they play with the Jupyter Hub notebook. But data engineers mostly they play with the SQL query in the data warehouse. BQML makes life easy for them now to do the prediction within the data warehouse itself, not with the structure, with unstructured data also. And it also bring the large language model for data engineers in the BigQuery. Okay, so now I'm jumping to the demo. Before that, any question from anyone? Yes, sure. Sorry, once again.
I've read the benefits of integrating BigQuery ML models in Vertex AI. I don't understand the ML ops capabilities. Can you elaborate on that?
Yeah.
Thank you.
Thanks for asking this question. Because without ML ops, because the current challenge in the industry, since you brought the ML ops topic, and previously there was a public event, Google Cloud Malaysia, that I was talking about, the ML ops. The biggest challenge is that most of the companies, they have developed their data science project, but the challenge they have is deploying those models into the production. And not just a one-time deployment, but also making sure that the models which you have deployed into the productions are being retrained automatically. When I say automatically, means that there should be a mechanism which trigger the retrain of those models. And those mechanisms and those alerts are like, the old data which were used to train the model, and the new data which is keep coming on daily basis, maybe in a batch mode. What is the, the data is skewness, and what is the data drift in the schema between the old data which were used for train the model and the new model. So all those, the part of the MLF framework. Now coming to your question, so BigQuery is mostly helping you to create a model, basically create a model, train the model. But after that, model get registered, model management is done by the Vertex AI. So there should be a single so we develop the code, right? We develop the code in Go language, Java language, but we need a version control where we can keep all the code, GitHub repository, Bitbucket, right? Similarly, in your organizations, when many data scientists are working, you also need a single repository. You also need a model registry. So Vertex AI is providing the model registry. I think Vertex AI is a bigger topic. I don't want to go in details, but the thing is, from the model management point of view, there are a lot of things which Vertex AI helps to do the centralized way. Feature store is one of the great requirement when you as a data science person start working. You need a feature store, and before train the model, you need to understand which features, which columns of the tables are going to be considered majorly or which may impact the output of the model. That is feature engineering, right? So that feature engineering what your one colleague has done, it should be stored somewhere so that it can be reused for the different models also in your organization. So that's why Vertex AI, that's the Vertex AI role. BigQuery, data warehouse, you can use, you can create a model. The model gets registered into the Vertex AI. MLOps part is completely in Vertex AI. Sorry, I gave the detailed answer because this is really one of the challenge I see couple of customers are facing on the MLOps side. Any other question before I jumping into the lab? Okay. Okay, before I start the image classification lab, I just want to show you the Vertex AI, how the Vertex AI looks like. The Kiwi was mentioning about the foundation model. So this is the Vertex AI. Here you can see the model garden. Model garden where you will see all the basic foundation models. You can select those models and you can start playing with those models. Depending on the task, you can select the models, right? Oh, okay. Hope you can see now. So this is how Vertex AI looks like. Sorry for that. So these are the model garden. Under model garden, you can see all the foundation model. So Palm 2 for text. So basically, as per your need, you can go and select the model, and you can start playing, start directly using that model through the API. And if you're not happy with that results, you can do the fine tuning of that model also. Okay. So now I'm coming to the lab, and this is how the labs are. The basically you're already I think running out of the time. So these are the steps which I mentioned already in the slide. You create a data set. You basically create a data set, big lake object table, and then you give the permission for the service account to get the data from the Google Cloud Storage into the BigQuery. So let me quickly show you where I keeping my all the images. If you see these are the yoga different pose, down dog, plank. So all the images are there. So these all the images are I'm going to refer into the and create a model. So very quickly, so this is the code. I think you already familiar with the code which I shown in the slide. I'll give the path where all the images are there and give the model type. Sorry, not all images, the model where I'm keeping. So if you see yoga pose, I'm keeping the model here. You can see saved underscore model underscore dot pb. So this is the model. We're keeping the model. And I already created the model and then creating a data set. So I already created a data set, which is a yoga underscore set. So under this, you see the model which I created. And then the parameters of the model. This is activation underscore 49. This is the the column which will show the prediction. And input underscore 1 is a column which is given as an input to the model, right? So input underscore 1 is the input for the model, and activation underscore 49 is a output of the model. Then I simply what I do here, I can directly show you the code. So basically what I'm doing here, this is the model I'm using it, which I created. And then I use the decode underscore image. And here you see the particular image I'm taking, particularly this image. and try to predict that what could be the pose of this image. So basically, I'm predicting whether it could be down dog, it could not be a down dog, right? So I'm not running the code; it may take time. So I'm just showing that. Hopefully, that would be okay. And this lab is also available publicly. You can access that, and also the video of the lab is also available publicly. I can share the link. The thing which I want to show you, how you can leverage the large language model in the BigQuery. So whenever you are trying to leverage the large language model in the BigQuery, this is how you create a model basically. Uh, BQML is just a data set. Normally you create in a BigQuery, but thing is important point is this one you need to give. Cloud AI large language model underscore v1. When you give this parameter, then it will establish the connection between BigQuery and Vertex AI. Then you can start leveraging all the foundation model of Vertex AI in BigQuery. So once I created a model, so my model name is LLM model. And the second query which I'm running is, basically what I'm trying to do, there is a table which I'm using it, the movie review. So I have a table which is, it's a public data set. It has a lot of movies reviews. So I'm going to generate a text. I'm trying to extract few keywords from those reviews. So let me run this. It's keyword extraction. And yeah, let it run. So basically, when you create a model in BigQuery, you can do the model evaluation also in the BigQuery, right? So this is how you can see this, the results. These are the different, so basically this is your reviews, movie review. And these are the keyword are being extracted here. Similar, another example is sentiment analysis in the same way. So basically the movie reviews are there, and the LLM model will help you to understand the sentiments of that review, negative, positive, yeah. But again, everything is you are doing in a SQL. So I think I'm already over the time. So if you have any question, let me know. Any last question from anyone? Okay. So one thing I would like to request, as the Google developer community, we are really doing great. But also, we are inviting if anyone wants to share in future, because I'm coming from the development background. I'm passionate about the development always. But any technical discussions and any technical sharing. So anybody from the Google, even you are in college, university, or in your company, if you're doing anything, let's do sharing with everyone. Reach out to the community members, and if you have anything to share, let us know. I think sharing is caring. Thank you.
Thank you so much, Arvind. That was really insightful. And of course, for those who has questions or too shy to ask, it's fine because we're gonna have a break later today, just up before this. So you guys can actually ask them your own personal questions, or maybe some demonstrations or what you may already have. All right. So, are you guys ready for a break? I know. All right. So before we do that, can we stand up a little bit? Because I have a feeling some of you guys are falling asleep. All right, so take this opportunity to stretch a little bit. Some of your shoulders might be stiff already. Just stretch a little bit. Take this opportunity to just freestyle. As long as you're not interrupting your neighbors, it's fine. Okay? All right, so I want you guys to turn around. See someone who you've never spoken to. Find someone, come on, come on. So I want you guys to talk about, okay, first, your name, what you do, what you're looking for today. Hi guys. Okay, so hi. Hi. Okay, so now that you got to know some like that person a little bit, I want you guys to ask them out for coffee because we'll be back here for our next part of the session at 3:30. So enjoy your coffee, enjoy your break.
Approach young looking people.
What do you think is stopping them from saying okay, what I do is when they say, I want motivation, even I share with them, everyone's on Google, they download as Excel. Excel, and then the first thing is column and row, so most of the column with, but you just, for me is I double click all the column and all the row height, it's okay. Yeah. But they don't want. Second thing about slide, Google Slide is when you change to PowerPoint. So yes, my colleague has mentioned that. So I'm very simple. Last August, when I joined the company, I started using Google because, like I told you before I joined this company, I've been using Google for years. So something you use. And I share with my colleagues because my team, myself, with the CIO. We will do real time on Google Cloud, and we open the Google Sheet together and we change the number together. We're very efficient. But other colleagues cannot, and I don't want them to feel comfortable because it's very on a daily basis. And when it comes to, let's say, when we renew, they may not want to change to Microsoft because one of my colleagues said, yes, we want to change, but everyone is up here. So from changing from Microsoft Excel, I need your colleagues have a direct really want to ask because I use that almost every day, and I can't use those systems. I don't know where it's from. And I have downloaded onto my laptop, my company's laptop, like Excel. I use Excel to do get the answer. This kind of little things that's natural. But the big environment is now working in both and everyone is not used to it, although they have subscribed to Google more than 5 years. So I mean, right, yeah, it's really at the best is good. And also with the 40,000 text for my I really so address my
The first one, so the GDG thing was done before. So it's a monthly thing.
no, because I think most people when they start but my
GDG Google development. Not going to almost monthly.
GCP Malaysia
sounds like a behavioral problem and rather than a knowledge problem because behavior is the reason why you're not having this.
But you're not having this thing happen.
And because of the behavior or the attitude, that is why you're not adopting or learning this. But that one is a human factor. But it's true that when you download from Google Sheet, it makes you feel but I have my way of I use my Excel. This and I'm Google this. But for me, I try not to use it because when I go home, I use my phone. And I always use my phone. Every day I share things like that. Just when you have everyone access
I don't need people to claim themselves to do those parts.
If you are Ethan, it's okay.
Anyone that can,
I don't know what they're using, but it's really cool. Instead of training the engineers
that's just adding more work for me. When I move the stuff, something is I have to edit together. They don't want to edit in Google Sheet together. because when you see the interface, they're already. Yeah, I mean, to me, it sounds like so you might want to address that behavior and then okay, my finance policy like just something that I don't remember we have that user with the user. They're talking about the formula for equal and yeah, there's some side so that's why I mean and then because once you have open up my mindset open wanting to change, that's when you can change. But they have technical they told us that maybe everyone can jump out of this because some yeah, your advertising because to really address the unknown problem. I'm one of the people that but we have to align this because we understand what we want is when we are on the same cloud and then a lot of numbers country and then virtually because nowadays I mean because of your technology and all that at the end I'm not we are the finance company. We would say I can actually spend 4 days. It's very fast. The class, the sharing is very easy. So can someone to go by maybe but for the first function answer as well. I go and have my breakfast. Thank you.
Exhausting, but
No worries. Hi everyone, welcome back. Okay, seems like there's a lot of empty chairs. I think most of you guys are still outside. So I'm gonna be inviting all the participants from the outside to join us back in because we're gonna come back with a new presentation relating to operation GCP. Okay, I was just about to say the whole thing.
Let me know when to begin. No, no. You didn't get anything.
All right, so without further ado, is everyone here comfortable? I hear a bit of a yes and then a lot of silence. Is everyone here comfortable? Okay, not too bad. All right, so we're gonna be starting very, very soon with Ash. He's going to talk about Operational Decision Intelligence Tool, or ODIN, a Kanban style tool for flight dispatchers. He's going to walk us through a little bit about GCP as well. So I'll give the stage to Ash.
Thanks, Alia. So my name is Ash. I'm from AirAsia.
Here to talk to you about a tool that we developed for our flight dispatchers to make their lives a bit easier, as well as save the company some costs and potentially generate some revenue. Do have quite a bit of slides to cover, but just a disclaimer. I know the past few presentations have been more about AI, AI, AI. This is not so much on that theme. It is more about GCP and how we've used the different elements to come up with a tool that today is currently being used in production and actively helping us save cost. All right, jumping in. Just a bit of information about Capital A. I'm sure you guys already know. So Capital A is our investment holding company. It has a portfolio of your aviation groups. It has Super App, Teleport, ADE, and I think in the airlines, we've got AirAsia Malaysia, Philippines, Thailand, Indonesia, and hopefully very soon, AirAsia Cambodia as well, soon as next month. So I myself work in the data analytics department in the aviation group. So I work for all the airline entities. And then we have my own counterparts in each of these other entities as well. All right, so moving on to what is Project Odin. So Odin stands for Operation Decision Intelligence. It was a tool that AirAsia and Google PSO actually actively collaborated together to with one goal. The goal essentially was let's take traditionally very legacy systems that were not built for the cloud in the aviation space, make them talk to each other, get all the data into one place, clean it, massage it, and then take it one step further, right? You have to also make it very easy to use, make it visible to the end user in a way that they can then take decisions in a timely fashion that can then aid them to save costs or aid the company to generate potential revenue as well. So what I'm going to try to do now, and I say try because I'm going to try to do a live demo, so to give you guys a good idea of the visual. So here's the front page. As you can see, it's a Kanban style tool. I'm already logged in, so you can see my name logged in over here. It's through Google IAM. Right now, I'm not a flight dispatcher, so my revenue and savings show as 0. What we have here are 3 separate verticals. You've got your new, in progress, and this is my resolved section. So what's happening here is that when the flight dispatcher comes in, they see the screen. They now know, okay, I have new events created over here for me to action. So let's take one, for example. I think I saw one here. Right, perfect. So this is a case where the cargo weight was decreased. So what's happened here is that when the flight plan, which was initially generated, that had 2 tons of cargo planned on it. But then the actual weight reduced down to just 2 kgs. Right? So that's a significant reduction in my cargo weight, which now means that I can carry less fuel on the aircraft. And when I carry less fuel, that fuel also has certain weight. So because of less fuel being carried, I am now burning less fuel to carry that less amount as well, right? Traditionally, the way we think about it is if I have more weight, I need more fuel. More fuel also adds more weight, so it's a multiplier effect, and that leads to more cost. So here, these potential savings that you see are what I can save now by burning that less amount of fuel because I have a reduction in my payload. So all the information here which you see is coming from a Firestore backend, and I'll go into the architecture in a bit. But the idea here is that the dispatcher can directly see when the flight is about to depart. They can see the relevant information about the planned and actual cargo. And then they can click on this additional button here for flight details. And it'll instantly generate in close to real time all the important information about where my flight is, the payload, the number of passengers, amount of cargo, my flight plan values, as well as even look at an activity log if they so required to. So this kind of gives them a one-stop shop to see all the information that is relevant, and then take the actions as necessary, right? Okay. Jumping back. Great. I just taken some screenshots in case my demo didn't work. We also do have a little notification pop-up that comes in whenever a new card comes up. So if the dispatchers are doing something else on their monitors, they can then see this and jump back to the screen. All right, let's getting into the fun stuff. I think which is why everybody is here for the know more about the architecture bit. So just the overview. We've got obviously a front end, middle layer, and a back end. Front end portion takes care of my web application and has my rule engine. Middle layer is for collecting my flight level data, collating it into one, and then you have your back end that gets the data from all of your respective source systems, right? So I'm going to dive into each layer a bit more on the next slides. Please feel free to stop me if you have any questions. Okay, starting with the backend. So I have 4 source systems: AIMS, Navitas, Smart Cargo, and NavBlue. AIMS is my flight operation system. Navita is passenger information. Smart Cargo is cargo, and NavBlue is flight plan. So 2 of my systems, we had direct access to the Microsoft SQL database. So we're using Airflow on GKE. We were able to create DAGs to directly get the data from there and push it into BigQuery. For Smart Cargo and NavBlue, unfortunately, we didn't have access. So we had bash commands running to sync the files into GCS. And then from GCS, using Cloud Functions, get them also into BigQuery. And then from BigQuery, we created pub subtopics. Because the idea was that the entire architecture is built on an event-driven thing, as you saw the pop-ups coming up, right? So everything has to be created only when something changes, when my flight information changes, more passengers check in, cargo decreases, etc. From there, we go to the middle layer. So now my 4 topics. You can ignore the fuel cost topic that was just created recently because we had such a variation in fuel cost happening. But traditionally, from the 4 systems, those 4 pub subtopics, you got 4 subscriptions that ultimately then go to my something called the flight updates worker, which is hosted on App Engine. Now, what this does is basically whenever a change comes in from a subscription, it understands that change and pushes that into my Cloud Firestore flight database that has all my relevant information on a flight level. So now I've combined passenger, cargo, flight information in terms of delays, as well as my flight plan information, all in my flights database in Cloud Firestore. Along with that, we've also created the same updates worker has one more pub subtopic that is now going. The objective of that was that I'll show on the next slide, but it was to allow a separation that now I have a Firestore as well as a topic created as well. Sorry. All right. So for the front end, I'll start as to how a user would log in. So when they first log in, they hit the load balancer, go through IAP for their authentication, and then they hit Odin Web, right? That's the front end app engine that the entire website was built using Node.js. From there, the app engine will call, Odin Web will call Odin Service, which also is on App Engine. And that would actually do 2 things. First, when you saw me load the page to see all the different events created, it would get that from Odin Store. So that's again in Firestore, so it's pretty fast. It's very efficient. It doesn't cause too much of a lag. Second, when I clicked on the flight details page and it opened up, right, and it showed me all the different systems, that's Odin Service actually calling the flight service API. That flight service API, as we saw before, flight service API actually is again going to my flight database, right, in Firestore. So the reason for that is that maybe after a card was created, and then when I clicked on flight details, the flight information already changed. So when I click that, it's actually getting real-time now updates from the Cloud Firestore again, from flight service. Now, okay, let's go coming to the bottom over here. I've got flight updates topic that gives me all of my information about my systems that is read by a subscription. And ultimately now I have to create the actual rules, right? So your Odin rule worker and your Odin flight update worker, what they're doing is effectively just seeing what are my changes which I've received so far in these flights. What are the, is it now reaching a threshold for a particular rule to be triggered? When I say rule, each of the cards that you saw, they were built on different rules we defined. Has my payload increased by 500 kgs? Has my payload decreased? Has something else changed, right? So when that particular rule is hit, that's when it goes into my flight rule queue, which is again governed by cloud tasks. And then that leads to the creation of a new event. When a new event is created, it gets loaded into Odin Store, and that's how my website then ultimately gets the entire card layout. The top portion for the batch worker, that is essentially is that once I have my information in Firestore, I also then don't want to keep too much information in Firestore because it will make my website very slow. So eventually what happens is every few minutes or everything few hours, it is actually doing a load from Odin Firestore back into BigQuery and then purging Firestore. So we use essentially a different table in BigQuery as my archival process. So I have the data present if I need to do any analysis, but I'm maintaining my efficiency on my website. Any questions so far? Yeah. Yeah, that's a good question, actually. So the reason we used App Engine was because it's completely managed service. We could have done it using GKE as well. We use GKE for Airflow, but because we're working with Google PSO as well, it was kind of recommended that we can go with the standard version of App Engine, which will auto scale based on our usage. It did increase the expenses a bit, I understand, but it also allowed us to scale pretty quickly. So we started off only with AirAsia Malaysia, but now it's serving all of our airlines as well. Another question we've gotten, sorry, go ahead. Our entire BigQuery is through Terraform. Infrastructure is built via Terraform, yes. This particular, I'm not too sure if we use Terraform for building a few of these. I have to check. But in general, AirAsia in our environment, everything is done by Terraform, yes. One question which we keep getting is that, in the previous slides, there were quite a few PubSub topics that we see, right? And I know that now with PubSub and the fact that we have to keep the website live and get real-time information means that we had to use RESTful long polling to make sure that data keeps coming in. And of course, now with WebSockets, it's much easier to use that instead to keep the connection alive. However, the fact that we are completely on GCP has made it that much easier for us to use PubSub and then the RESTful long polling, as opposed to then having to either use, I don't know, socket.io or something and try to create our own customized version to create WebSockets. Also, it's an event-driven architecture. It's not, there's no need to have a two-way communication. We can kind of be okay with having it only driven one direction, right? Sorry, I saw someone had a question there. Yeah, okay. All right, interest of time, I'm going to move on. A few security features we implemented, definitely user access through IAM, governance as well to make sure that only when I log in, I have admin access, so I could see all of my AOCs. I could see Indonesia, Philippines, Malaysia, but if somebody else from Malaysia logged in, they would only see information relevant to Malaysia, right? So kind of row-level governance. Then we've got your service communication, obviously, is through the GCP services. For audit, everything is stored in BigQuery, so I can always go back and check. Only level 2 data, so no PII information, so that made it much simpler from a governance perspective. And for observability, logs in Stackdriver, and then again, logs also using the log bucket, we're able to push it into BigQuery as well. Some of the issues that we faced and what we learned. So I think this is maybe true for many of the products or tools that have been developed at your respective companies. Developing trust in the data was actually a great challenge for us because these flight dispatchers found it very difficult to believe what we were showing them. They said that no, my system says something different, etc., etc. So how do you gain that confidence in your tool, right? So what we did is we added in a updated at timestamp under each of those data sources. So when they open it up and they saw that the update was so recent, they're okay now to proceed. Gave them a little bit more confidence and some assurance that they could actually trust what we are showing them and then proceed from there. Uh, another learning we had was once we went live, we actually had too many notifications, especially during, I think we went live sometime of March, April last year. It was still when we were bouncing back from COVID, and a lot of our flight planning was everywhere, so people didn't show up for flights. So we had so many of these cards coming up, but the dispatcher said, "You're spamming me. I cannot do my own work, and please, shut the tool." So what we did from there is we actually added some more sanity checks to the logic to make sure that if there's certain things which come up, like if I'm getting a notification for a flight that's going to depart in 20 minutes, I'm anyway too late to do anything, right? So then I will just not show it anymore. Additionally, for the other AOCs, other airlines, you have cases where, let's say, Indonesia domestic flights, the check-in shuts at 40 minutes, but Philippines at 45 minutes, Malaysia at 1 hour, except for example, right? So we try to create some more dynamic parameters there to make sure that the rules were not so stringent, and then we aren't spamming people with unnecessary information. Yep. All right. So we weren't really finished there because after we built the tool, the management kept asking us, all right, you all went ahead and built something. It was pretty expensive. What is it actually doing for us, right? Like, how is it performing? So to do that, we actually did two things. Of course, we had reporting, but we also tried to introduce a bit of gamification to promote the dispatchers from taking these actions so that they could, do some cost saving. Um, this is one of the dashboards we had built. This is entirely on Tableau. The numbers are fictitious, but what we tried to do here is introduce a bit of gaming, so I can see there's a real dispatchers, and I can see that for this month I have done so much of savings. I got so much of value, whereas somebody else has not. So you try to create that competitive edge to make them want to go and take those actions, and which ultimately leads to the company saving money, right? Additionally, one more interesting feature we added in was about the CO2 savings. Not that it's definitely important, but it sometimes was not mattering to the dispatchers that much. So we try to change their mindset as well, that if you're burning less fuel, I understand that maybe that additional fuel saving is not coming into your paycheck, but it is helping the environment as well, right? So you're able to get a little bit of buy-in from them because people care about the environment, I guess. Moving from there, for management reports, we again had, like, they have, I think, a monthly meeting with the dispatchers. So we had your ranking on the right hand side there for all of the dispatchers, and then when you click on it, you can actually drill down deeper into how much of value they've added as well as how much of value they've lost. When I say lost, I mean it because they did not action a card or they rejected a card, which came up. So this kind of gives you, okay, now why did you reject something? I double click that, and then the bottom table will give me all of my base level information that so and so happened at so and so time, and that's why I rejected something. So you're trying to improve their performance as well, which ultimately would lead to a positive feedback loop. And finally, for Teleport, our cargo entity, what you're seeing here, the planned cargo and actual cargo, it's relatively close by. But when we started off, we were off by like 50,000, 100,000 sometimes. It was a lot. And that's because they also had no feedback mechanism telling them how much, sorry. We didn't have any feedback mechanism telling them how badly they're planning something or how good they're planning something, right? So this sort of gave us a bit of an advantage here, because now when they can plan better, we can also then less chances of us offloading cargo, delaying flights, or doing any of those other things that cost us money, right? And of course, if I can plan better, then I can take more cargo, I can get more revenue as well. Okay, really quick into the next steps. So I know because this presentation is more about, I mean, this session today is about AI. We actually have taken it a bit forward. What you're seeing today, right now, is just the base level which we started off with last year. From there, we actually now have a new initiative called Sky IQ that's going to go live hopefully by the end of November, which is going to be building on Odin a lot more, where we'll be integrating things like delay prediction, where I can potentially swap an aircraft beforehand by predicting that a delay is going to occur because of few, maybe weather, maybe some other flight got delayed somewhere else, the snowball effect. And when I know that, then I can also call up crew beforehand, right? So if I know I'm going to have a shortage of crew, or because of my flight delay, now my crew has reached their limit of the amount of hours they're allowed to fly. We call that the FDP period, right? So if that limit is going to be reached, I should have a standby crew waiting beforehand itself on the ground so that my flight doesn't incur any other delay. And also, this will help with early warning with ATC. So I'm sure all of us have at some point experienced being in an aircraft where it just goes in circles above the airport, right? So if we are able to predict beforehand better and give that information back to ATC, maybe we can help in the planning process as well to avoid or to minimize that holding period, right? Uh, Additionally, we also wanted to make it a bit better for our flight dispatchers to understand what are the main reasons someone's rejecting a card. If I understand that, then I can automatically modify my rules also to now not show that card anymore. If those sequence of events occur, then that means they're most likely to reject the card, so I will not show it. And also now extend this to one more persona, from flight dispatchers to even crew planners. So I know that, okay, on this particular day of operations, today I just have a list of my standby crew, and I'll pick one at random and I'll call them up. What we want to do is actually look at past behavior as well. Look at if it's, for example, I can guarantee you that this Friday coming up, we're going to see a lot of crew on MC and not reporting because Thursday is a holiday, right? So that those kind of behaviors can be predicted, and we can at least have some additional standby crew present in case that actually does occur. All right, perfect timing. So some key takeaways from this. We've been live for, I think, around 13, 14 months now. We've got around 75,000 events that have been actioned that has led to an actual validated saving of 272,000 USD. This is all due to the fact that because I'm now carrying less fuel, I'm burning less fuel. We are not considering the fact that I'm loading less fuel on top, because we have our own fuel contracts and that anyway that payment has to be made. So that is not being considered. Only the fact that I'm burning less fuel is what's going into that much saving. Uh, I think, as like you asked, we had quite a few different services, and we tried to make it as much based on microservices as possible, so it can be plug and play. So now, for example, Sky IQ, like I mentioned, will be using some of these microservices as well. So we don't have to start from scratch again, right? We can really speed up that process. And lastly, the design. I know we are all tech people. We like to focus more on the back end stuff, but having a very simple, easy to understand, familiar Kanban style design really helped us actually sell the tool and gain adoption as well. To get 75,000 cards being actioned by these dispatchers who have very busy day-to-day jobs, right? It was quite the task, but because it was so easy for them to accept, it led to the success of our tool so far. I think that's pretty much it. And that's just me saying thank you. Any questions? Yeah, sure. Mm-hmm.
The most common one or the top predictive models for the application, yeah.
So this one so far doesn't have any prediction coming in. What I was referring to is our other Sky IQ project, where we are going to be utilizing some of these predictive models. I do not think I'm actually at liberty to tell you which ones we're using,
Okay.
but I would say it's a combination. Right? It has to be. We can't build everything from scratch. So of course, some things are going to be utilized, which are pretty common. Some are just something which we're building ourselves. Yeah.
Any more questions?
Yeah. He has one.
With hindsight on your side, what would you do better, or what would you want to change if you have a greenfield
That's a good question.
in system architecture, I suppose?
Okay.
Then maybe I change question.
No. It's a good question. I haven't thought about it that way, but in terms of system architecture, I think I don't know if I would change it, but I would say we only realized the problem of keeping the front end live, the long polling, pretty late in the game. So we built everything, and then we had the up and running, and then the users complained. So what? I have to keep refreshing my page to see new things, and that's when we realized, oh, we didn't consider this while developing it. We were able to find a solution, but I don't think personally it's the best solution out there. We could have got something better.
Was that due to the architecture of PubSub, or like a streaming service that you're looking for?
So yeah, we don't have a streaming service. We don't use Apache Kafka. We don't use any of that, right? So it was all based on just on BigQuery right now and GCP. So we chose PubSub because it's event driven, and it's a managed service. But then we didn't really think about the keeping it live. So then that only came at a later stage. So that was actually our mistake, not really the architecture's fault, but that's a learning that we also had. Yeah.
Thank you. Something I learned as well. Thanks.
Yeah.
All of us, let's say flight delays are money to everyone, right? Do you have that? Do you have that kind of model, or you plan to have to reduce the flight delays for whatever reason, whether it's the parts, the plane parts, and so forth?
Yeah. So there are many different different types of delays that can happen as well, for various different reasons. So we do have different models actually helping us try to predict when a particular delay happens. And also, I'm going to go even more old school. This has nothing to do with prediction, but just something which we call save me flights. I don't have a picture of it here, but what that means is if I know my incoming flight is going to be delayed, I can use that information. Let's say I know my incoming flight is going to be 20 minutes delayed, right? So I can then send a notification to all the people on the ground that the incoming flight is now 20 minutes delayed. So please start lining up the people beforehand. Get the cleaning crew ready. Make sure the boarding gate already is present. Fueling bowser is present. Try to shave off those few minutes. So at least I can try and reduce those 20 minutes down to maybe 10 minutes also. It sounds very small, not many of us would even realize 10 or 20 minutes, but those 10 minutes actually make quite a big difference toward our KPI for on-time performance. But that's not really prediction, as just timely information. Yep. Yeah. Okay, he has a question.
Sorry. My bad.
So based on the architecture that you have presented, there's a lot of elements and systems that are involved.
Yep.
So how do you address your DevOps, and how do you measure your metrics for each of those systems or each of those managed services?
That's a good question. So we've got a whole DevOps team that actually is completely separate from us and who's managing that for us. It is a combination, I would say, of us working alongside the Google PSO team as well. So it's a collaborative project that we work with them. At that point, when we just began, our DevOps team was relatively small, and learning with the PSO team, we've actually grown from, I think, 4 or 5-person team to almost a 15-person team now, whose sole responsibility is to make sure that all systems are up and running, and that if there's any issue, it's called out way ahead of time, and the logging as well. Yep.
Bottleneck check.
Yes. Correct. Yeah.
your data model already appropriate enough to start training for predictive models?
Yeah.
But so in a situation, let's say you missed a couple of key
Mhm.
data points, how would you address that?
So the beauty of it being in BigQuery is that now, let's say, I think I can go back to the architecture slide. Sorry, I know I'm a bit over. Where was it? Yeah, all right. So the beauty of it all going into my operation data lake, that also houses information from my other projects. So this is only talking about these 4 systems, right? But we also have data regarding, let's say, my in-flight sales. It also has information regarding my warehouse management system, et cetera, right? So all that also resides in the same data lake. So utilizing the very nature of what BigQuery was built for, and what Arvind also mentioned, we can now use the native BigQuery tables, join them together as required to get additional features, as well as the data, I think you call it the big lake tables as well, so that then you can build your own models after that. Okay, great. Thank you. Thank you so much, everyone.
Thank you, Ash.
I just want to say thank you so much, Ash, for coming on the short notice and sharing with us. Thank you so much.
All right, so for our next speaker, we will talk about optical character recognition, or OCR, with document AI using Python. So I would like to invite Miss Kristen T to the stage. Oh, no. Give us a quick 2 minutes, so we'll just sort this out. And you just need to share your screen. Ask to join us. So, yeah, we can start from 7. Shortly. Okay, great. Yeah. Yeah, it takes a while. Okay.
So I do not need this one. Yeah, actually do not need it. Okay. All right.
Okay, sorry for the slight delay on the sharing. Okay, hi everybody. I'm Christine. I am one of the senior machine learning engineer in Turing Enterprises, a company in the US, and I'm also a co-organizer for Google Developers Group Kuala Lumpur. I am also a certified TensorFlow developer. So today I will be talking about optical character recognition, OCR with document AI. So here's my LinkedIn URL if you are interested to connect. So so what will we be talking about is a business challenges. What is document AI is exactly solving? An overview of document AI. How do we configure and create processes using document AI in Google Cloud Platform? It is a demo. We will be demoing on online processing and also batch processing with document AI. A little bit of overview about document AI Workbench. This we will not be demoing because it will take a while, but we will just be talking about what does document AI Workbench do. And lastly, we'll be talking about human in the loop, HITL. Okay, we'll be looking into what it is. So the problem with documents, I mean business problems. One of the business problems that we have is too much documents to process. So businesses all over the world rely heavily on documents to store and convey information. So this information has to be digitalized because if you have a company, just like I do. So at a side note, I also own a digital marketing company. We serve clients all over the world. I have right now about 40 plus clients around the world. So one of the problems that we face is we have too much documents to process. Like if you are, especially on tax seasons, like invoice, receipts, and maybe you want to process like customer feedback forms that you pass to people to handwrite, and then you need to extract information from it. It is a bit hard when you have a lot of it. Yeah, so this kind of information that we are unable to quickly process, or it is like handwritten, jumbled out, like very difficult to process it in a short while. We call it the dark data. So we need a way to process it quickly. So this is how document AI is coming in action. Yeah. So yeah, this is just the main challenges that document AI wants to improve on. The first one is manual labor. So a lot of handwritten data, they need manual labor to process it, which is a little bit difficult. It is not only costly, it also takes a lot of time. Secondly, in efficiency, you also face a problem with too large of a volume, making it like very difficult because it will incur a lot of operational costs. You need to hire a lot of people to do it. Inaccuracy, there are human errors that can involve in terms of processing things. It always happens. Noise in documents. Yeah, this is about documents that are written in handwritten text. They are not easily readable, making it difficult. Okay. So what exactly is document AI? It is a document understanding end-to-end cloud-based platform that takes like unstructured data or so-called the dark data from documents and transform it into structured data, making it easier to understand, analyze, and consume. So document AI uses machine learning and Google Cloud to help you create scalable end-to-end cloud-based document processing systems. So to name a few, document AI actually uses things like NLP, computer vision, translation, combine it together and then provide these services to businesses for you to use. So it is capable of doing all these things as seen. So it's capable to pre-process information, pre-process document with image quality detection and descaling. It extracts text and layout information, identify key value pairs. What does it mean by key value pairs? Is that, for example, you have a form that you have fields and the data, and they can identify it and pair the two together. Okay, so, and also split and classify document by types, extract and normalize entities, label and review documents, store, search, organize, govern, and analyze data, analyze documents and metadata. Okay, so this is the components of document AI. So the first is to do document prep, classification, entity extraction, entity relationship, uptraining, and repository. So these 6 components makes up document AI. Okay, and there is a human review at the bottom, which is just now we talk about human in the loop. So after document AI, there is something called human in the loop, where human can validate whether the machine learning models identify the data correctly. Yeah, so this document prep, classification, entity extraction, and uptraining is what human in the loop can like double verify it. Okay, so so to use document AI, first you need to create a processor first. So what is a processor? It is an interface between the document file and the machine learning model. They are used to classify, split, parse, or analyze a document. So each of the Google Cloud project need to have its own processor instances, which I will have a little bit of demo later on how to create the processor in GCP. So there are a total of 41 processors that you can create in document AI, but these are the category of it, because most of the specialized processor type are catered for US document types. So the text documents, the invoices that are in US standard. But since we are in Malaysia, we won't be able to use a lot of the specialized processor, but we can use the general OCR processor, or we can customize our own model in document AI. So the general model is a pre-built processor that is compatible with most of the documents. If it is, if you want to use a bulk, perform OCR on a bulk, or a general like text in text document, it should be able to do all. If you have a very specific use case, you can customize your own model in Document AI. So the step is to choose the processor that's suitable for a use case. And the second is to create the processor on the Cloud Console or the API, and then send the document for processing. This is the flow of Document AI processor, which we will demo a little bit. So here is the use case. Yeah, the use case of it. So for example, if you want to extract text and layout information from document, or if you want to analyze the scan image quality from the document, you can use the general document OCR processor. If let's say, if you want to extract tables or key value pair from a structured form, you can use the form parser processor. So the other few ones are for the specialized processor use case, which we are not able to use because, as I said before, we are in Malaysia, so the US like tax invoices format will not fit our use case, but you can still customize your own model in Document AI. So there are two ways you can manage your Document AI processor. So one is manually, which is on top from the web console. Second is programmatically, which is using terminal, using Cloud Shell at the bottom. Okay. So if you want to look at, if you want to just try using Document AI, you can go to this link right now. There is a demonstration on Document AI. So if we click on this, yeah. So you can see that it is a demo that you can upload your own document, or if you don't have, you can just use one of their sample. So if I use form parser processor and I upload my document here right now, it will extract the data from the form. So right now it's still running. Yeah, okay. It should only take a little while. So this is a form. This is a form on health intake form. So what you can see right here that it has the, okay, let me, maybe like this. Okay, so it has, if you see, like it has the date, it has the date, it has name, address, all this. It means that they have paired the field together. Oh. Yeah, so DOB is DOB, name, address, the zip code, state, city, and the form is handwritten. So you can see that the accuracy is quite good because OCR is actually a very mature technology. So it can extract decently well. Oh, here you see a little bit of mistake here and there. It can happen. So there are other things that Document AI can. Oops. So these are the OCR tags. OCR tags, and then you can actually pass this into a JSON format right away. Here. So these are the key value pair for using form parser processor. Okay. So right now I'm going to show a little bit on how to run document AI in Google Cloud Platform using Cloud Shell. Okay. Original image. Hold on, yeah. This. Okay. Do I? Do I can see? Yeah, okay. This is the handwriting, a handwritten form. And this is the detected output right here. Yeah. So you can say that you can see that the handwriting is very like messy. Yeah. So okay. Yeah. So okay, right now, for the demo, we will start by creating a new project in Google Cloud Platform first. I mean, Google Cloud. Yeah. Because of time limitation, I have already created the project. So let me share these. Oh, wow. Okay. Okay, let's reconnect to this instance. Okay, so okay, so to start, we have to create a project first, which I have already created right here. So this is my project, and this is the service accounts. As we said earlier, we have to have a service account. And then you activate Cloud Shell, which I also activated. So after you create a project, you should see your project ID there. Yeah. So in my case, everybody's project ID will be different depending, like, because the project ID has to be unique. So right here, we are going to we are going to run all this. So first step, make sure you're authenticated first, and then to make sure that you are working with this project. If not, you can set the project ID to this, because sometimes when you have a few projects in Google Cloud Platform, they might get confused on which project you're working with. And the final line is to activate document AI. So and then the next step is to navigate to document AI platform, click explore, and then select document OCR, and then give it a name, and then create. So after you create, there will be a processor ID right there, which we need to remember for later. But don't worry if you can't remember, because you can always go back to the interface to recheck. Oh yeah, this one is in order to make requests with document AI, you must have a service account. So what is a service account? A service account belongs to your project, and it is used by Python client library to make API requests. So like any other user account, a service account is represented by your email address. So And then the next step is to set environment variable with your document ID, and then create a new service account to access document AI API. So this is, you can create this from the terminal here. So I think let's do it right here. Share this instead. Yep. Let's run everything. So make sure you are working with the accounts that you are working with. And then make sure your project ID is this project. And then, yeah, I'm just running the code that I mentioned just now. So let's give me a bit of time. Yeah, so operation finished successfully. And then you want to set your environment variable with this project ID. And then you want to create a new service account. I'm not going to create a new service account because I have already created one service account here. So this is the, after you create the service account, it should appear right there that this is the service account that you are working with. So the next code, the next one is this one, which is which is this one, is to give permission for the project to access document AI and cloud storage. Okay. So we will look at here. Oops. Okay, I think due to time constraint, I cannot be running all this code, but I can show you the outcome of it, okay? So, right, I can show you the outcome of it later, but this, the next step is to install the Python client library, and then we download the PDF to perform OCR with. So this file is a book. We need a pull book, and then we shall make an online processing request for it. Okay, so share this instead. So for this one, for this online processing Python file, it is this. It is shown here. Okay, so what do we? So we will use this file, but what we need to do is to replace our project ID, our location, processor ID, and the output URL. Okay, and the input URL. So this is for batch processing. And this one right here, it is for online processing. So the difference between online processing and batch processing is that in online processing, we have a limit on how many pages we can process at the time. So we have to use batch processing if we have a larger or multiple files. Okay, so yeah, this one right here. So we will process we need the pull novel with the document AI batch processing API. And this code is to download the PDF to perform batch processing with. And as I shown earlier, you replace your project ID, your processor location, processor ID, your input URL, output URL. So, okay, let's look at my cloud bucket. Yeah. After you process, so I'm showing you the outcome for batch processing. So the book has 180 page, so it will take a while to run. But after you run, you will have all the output in JSON format in your Google Cloud bucket. Yep. So it's straightforward as that. Okay. So so the next one is Document AI Workbench. Document AI Workbench allows you to build, train, and build and train your own tailored processor from scratch. Okay, so there is two things that you can do. You can uptrain, or you can customize your own processor. So there is three types of processor, three types of custom processor, custom document extractor, custom document classifier, custom document splitter. So three of these things actually do different things. So depending on whether or not you want to identify and extract entities, or you want to label and train your model to classify your document, or you want to identify your document boundaries. So you can choose different custom processors and customize to your own needs. So this one is up training. I think I missed that just now. So up training is that you can use a pre-made model, and then you train this model with your own data to improve accuracy. So because there are certain cases where the outcome of it, the output of it is not as accurate as you wanted, and then you want to train with your own data if you have your own data set. All right. So if you want to understand and learn about uptraining a model, you can use this URL for a code lab, so that you can do step by step on how to do uptraining. Okay, so the last one is human in the loop. So human in the loop, it enables human verification and corrections to ensure accuracy of data extracted by document AI processor. So it provides a workflow and UI for humans. So the human is labeled as labelers in human in the loop to review, validate, and correct data. So this process is used in financial services, health, manufacturing, government, and other industries. So some of the features is right here, but basically is to improve your confidence score. It is to manage your labeler. It is also to reduce your handling time, and by having a UI queue and features, and it also has analytics and metrics. So yeah, as I mentioned just now, human review can be performed in document prep, classification, entity extraction, and uptraining. Yep. So this is the cycle of it. The step highlight in blue is where human can involve. So there are two types of human in the loop workforce. One of it is is using your self-managed workforce, which is using your own workforce to do human verification. And another way is to use a Google managed workforce, but this isn't available in Malaysia. So this is right now available only in the US and EU. So but for Google managed workforce, the team will be based in India. Yeah. So this is all of it. I believe I have went over the time. So thank you very much. Yeah, you can reach out to me later, or you can LinkedIn me as well. I'll check. Yeah. Yeah. All right. Okay. Thank you very much. I will pass it back to you. Yeah.
All right. Thank you so much, Christine, for that very insightful session relating to document AI, changing how we work and making it more efficient. Okay, so I wanted to do a little bit of breathing exercise because I feel like a lot of people need some oxygen in their bodies a little bit more. All right, so I'm gonna count from 1 to 10, and I need you guys to inhale as much oxygen as possible, right? So let's start inhaling. 1, 2, 3, 4, 5, release. Sorry, that was not 10. I realized how slow I count, so never mind. All right, so can we try this one more time? 1, 2, 3. Exhale. Feels different, isn't it? All right, so I wanted to give the floor to our next speaker, Lai Fong. Give us 2 minutes. PZ and C dash GG. It's okay without mic. Without. This is only presenting it. It's not looking. It's how's that?
Good evening, everyone. It's a very long day for you guys. I hope you are still awake for the next talk. So, how's it going on? To get started, right? May I have a show of hand? How many of you are working with data and ML, especially on data, like all this fraud detection? There's some ideas, some basics. Others, something new to you, right? Okay, cool. In that case, I will have a better idea how should I start with the more towards basic, towards intermediate, or directly jump to the details. Cool. Then I will start with a bit of introduction with how to get started and all for you to get some backgrounds into what we are talking today. So today I will be sharing actually it's a fraud detection system using Google Cloud technologies. So it's from end to end, from the raw data to AI machine learnings with all this model training and all, with BigQuery and other technologies. So for the flow of today, I will go through the introduction, a bit of background on what is fraud, credit card fraud is in this use case scenario. Then a bit of background on all this fraud and then fraud detection system. Then we will go into our use case scenario, start with the data set and the EDA. EDA is an exploratory data analysis whereby before we get started, right, we need to understand what is our data, what is inside our data, what are the tables contains, what are the features contains before we can even get started. So after that, then once we have a clear understanding on what is inside our data set, then we can plan like how are we going to train our model to be able to detect the fraud. So then you will getting into a process of feature engineering where we will select what are the useful features that can be used for our model training and prediction later. So let's get started. Introduction for our use case scenario here. I have mentioned that we are using the very real life use case scenario. I think a lot of banks industry and also the companies will be very interested on doing this on fraud detection. So credit card fraud, right? Everyone has a credit card, right? You always get scam calls once. Yeah, credit calls to, yeah, right. So it's trying to get your credit card details. Then suddenly you receive, oh, you are purchasing iPhone from Shopee, but you are not. Someone is helping you to buy using your own money, but they will get the iPhone, right? So it's happened all the while universally, and it's actually causing a big loss to the banks, especially. So then as we understand, it's just a credit card fraud case, right? But then internally, it can be actually categorized into two. One is we call it card present scenario. The other one is card not present. Anyone who can give a hand, simple question, right? Who can try to explain what is card present, what is card not present scenarios? Can you give some examples? Yes. Right, cool, very interesting. Thank you. So like card present, right? It's very, very direct, right? Card present is, let's say someone steal your credit card, then they use your credit card to fill up petrol or whatever, to buy some things, right? So this is card present, where the fraud case happens whereby the frauder using the credit card. The credit card is there. So the second scenario is card not present. This is where your always is the card details being leaked out. They get all your credit card credentials, your credit card numbers, the CCV, the expiry date, and all. Then they can just fill up the online purchase without having the card, but with your details. So this always happens when there's a data leak. They get the data, your data somewhere, somehow. So we have two use case scenario here. So as we mentioned just now, right, this is a global issue and it's causing a big loss also, right? In this diagram, right, what we want to show here is, I know it's not up to date, because the data set that we're using is actually a historical data and it's towards the 2018. So based on the graph of here, right, so it's actually showing the value of total loss from the credit card fraud case. It is grouping into different category. The CNP is the card not present. The yellow one you can see is a big amount. It is actually taking like towards the years, every years it's getting at least like almost 70% of all the credit card fraud case. So the credit card fraud case majority happens in CNP scenario, where the scammer get your credit card details and then they just do the online transaction for you. So this is from the this one I think is Europe bank sharing scenario. So here's the case, right? But then for the POS and ATM, POS is stand for point of sales, the terminal one, where you get the transaction happens in the ATM machine and all. The case is relatively much smaller compared to CMP. So we want to attack or detect all these CMP cases. But how? So there are a few in the credit card fraud detection system, right? They are actually having a few blocking layers. So the first two layers is called terminal and transaction blocking rules. So this is where it happens in real times before the transaction or the authorization. So it's somehow you get alert, then it's trying to stop your transaction going through. The second layers is scoring rules and data-driven model layers, where it's executed in near real time to block the potential card. An example for this, right, is like sometimes you get an SMS alert that we receive a transaction of 8,000 from Shopee. Have you done this transaction? If not, please call the bank. So this is where it's trying to like detect, is it a fraudulent case? Then if you call the bank, then you directly terminate this transaction. So the final one is the investigator. The one is a bit late already, like when humans, they go to investigate, find out like all these detective case, they want to find out the scenarios. Is it really a fraudulent case or not? It's always after the scene and offline. So this is a bit hard. So what we are looking into today is the data-driven model, because we are data and ML, right? So in all, right, we can have a better understanding or background on all this credit card fraud and credit card fraud detection for the start now. Okay, right? Can na? Later got quiz, no lah. Now, so we are saying that we want to do the data-driven model, right? So for those who are working in data and ML field, we know that from data to AI is a long journey process and involve different technologies and processes in between. It's not like just directly getting the use case like software engineering. You design it, then directly you can just implement. You need to get the first thing you will ask, where is my data? What are my data? From there you can start to understand the data, clean the data, see what is useful, what is not, what can be used. Then from there you slowly go into the AI and ML part. So it's a longer process, but then it's what can drive, because it's bringing the insights of the real world real case, right? What is happening, right? So it brings you better insights or better understanding on what is happening for you to make informed decision. So for now, this particular person is always do a purchase end of the month, a big amount. So maybe got money already, salary in. So this is his habit. Then from the understanding, from the insight, then if end of the month, August, maybe it's another Merdeka sales, buying something again. So maybe this one is not so highlighted as a potential fraud case, because this is the purchase habit from this user, right? So we need to understand from the data, then we can help in the application side what we can do to, let's say for this case, is prevent the loss. So back into our use case scenario, right? So we have this bank. I don't know if it's a real bank or not. We call it Simba Bank. So the data is from, the ingestion is from this bank. And so what is inside, right? Imagine we want to showcase the comprehensive data from data to AI journey on the Google Cloud, right, using this use case of real-time fraud detection. So to begin with, imagine that you have joined the data science team of Simba Bank. This one is one of you. Oh, congratulations. So in the first meeting, okay, now your manager comes to you. Your product manager comes to you. This is our fraud detection system. We have the incoming transaction, we have the rules, then we check the transaction using our in-house rule, then we will check is it a forwarding case or not. If it's not, then we accept the transaction. If we think it's a forwarding case, then we will send the alert to the next process will dispute the transaction, or maybe there is another checking layer. But then it can also feedback to the rules is successful blocking the transaction or detecting the fraud case or not. What do you think about this system? Hey, you are working, data scientist hired, probation. How? No, not real time. Not real time. Any other feedback? No, you wouldn't get fired if you mentioned wrong. It's okay. Anyone want to try? Sorry? Complexity of the rules. Yeah, this one is maybe it's just if else, right? It's not so AI, right? So yeah, you catch it. So then the challenge is it could be biased. The rules can be biased, and it's hard to scale. It could become complex, and it's hard to maintain. So this is the company scenario right now. We have the fraud detection system, but then outside externally we mentioned we are using data and AI ML, but inside you got it right. Inside maybe it's just if else rules comparison. But yeah, so we want to improve it. So then how? Any idea? Your AI, how? Ask ChatGPT. You try and see if you can get a good answer or not. AI, we change the rules to ML model. Good, very similar. So the next question is, how are we going to develop the ML model? You got the idea correct, but how? The next question is how. Let's see how. We want to do modern data-driven fraud detection system on Google Cloud. So how? Then the team, okay, we get the task, right? The project, the task. Then we brainstorm how and all the technical team. Then we come up with the design. So I will briefly go through. It's a lot. In fact, I can't even cover everything for this session, but I'll just go through the main idea so that you can understand the blocks of it. Then afterwards, you can go through the in between with you. I will share the links on all these materials to you. So, like I said, right, from data to AI is a long journey. It's not just directly you get the task, you just develop a rules or implement it, then you can get it run. So that one is traditional rule-based, right? We want to get the ML model one. So now the first part is on, I'll just briefly go through. The first part is on live data source and from the raw data ingest to our data warehouse or data lake first. So this is one process. We need to collect the data, right? So in here, we will use different technologies. The injection part is a live streaming. We can use PubSub. Then the data warehouse or database, we can use the BigQuery in Google Cloud. Everything will be in Google Cloud. So then after that, we have stored our data inside our database, lake data warehouse, right? We want to use the data to understand the data because before we do anything, we need to understand it first, right? So then it comes to the next process. You know, if I can see a pointer. Here, we need to go through this EDA process. We call it EDA in short is exploratory data analysis. I'll give you a few examples what we want to cover in the EDA. For very simple example, like it can be like how much of daily transaction we are getting in. Right. We can't really simply just give any numbers. It is based on what is really happening inside, and we can get it from our own data. So all these things, after we have understand our data, then we will do feature engineering. We'll use a few things. We'll use the BigQuery, then we will use the Peatix AI. After that, we can sift the feature. Generally, we can save all these feature inside a feature store. Then after that, we can use all this feature to do the model training part. So after from the model training, we deploy it, then we can do the inference. Inference is just calling the model to get the prediction out. Okay. Okay. So far, any questions? Yes. 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 Yeah, you can have the feature store in BigQuery also. But for today's use case, we are using the feature store in the Peatix AI. So, okay, can do timeline we see if we can manage to do it. So before we start, right, we want to understand the data, right? So in this step, data warehouse, straight go to the data warehouse. What is inside the data set? So for our use case, right, it's actually synthesis from this this link is from Geiger fraud detection handbook and things like that. This link will be there. So it's actually synthesis the data set from this side, and then you will just ingest into the BigQuery. So these are a few characteristics in the data being synthesized. So to represent some real world data. Now, next, the one will be a bit lengthy and all right. We directly look into the data set. These are a few data set data set table that we have. One is TX. TX stands for transaction. Then the demographics, and we need to understand the customer profiles. No sensitive data inside. Or normally we will just mask the data, sensitive data, like the name or IC and things like that. The terminus is the terminal sales of point of sales. Then the customer terminals, we want to aggregate the customers and terminals two data set into one data set, so that we know which customer is doing some transaction in which terminals. Still okay, still can do the task. Not resign it. For this part, right, coming into this part, right, I will be maybe I will directly switch into the GCP side already, but I will just give you a very brief point to get started. EDA, right? So this point, in the sharing data is using the notebook, but it's just a simple as a SQL query You can do it in BigQuery, like one of our friends shared just now. But for this time, we are using the notebook and run the query inside, so that everything is, you can run all the steps inside one Jupyter notebook. So let's say we want to select all this data from transaction table. And then this is the result written. So in here, you can see like the transaction ID and then the time, the date, the customer and all. So this is how it looks like. Okay. So next, then I will, I'll go through first, but then I will switch to the GCP notebook already. So then the next, after we go through this, we will do the feature engineering and then the model training part. So let me go through here. So you can see, right? Right. So first thing first, this is the BigQuery. Who is seeing this GCP console the very first time? Anyone? Okay, got join GCP boleh ya? Got sweat coming soon So then I don't explore all like the introduction or background on all this GCP platform. So then this is the BigQuery side. So we will look into the tables. Some of it, because I have already trained the model, then you see the model. But then what we want to see is the customer tables. This is the feature names, the column names. And then we can also see have a preview of this. Yeah. So now you understand why we need to understand the data first before we do anything. Because everything is just number. And you can just put anything. Right. So this is the customer table. I will just walk you through a few. Then this is a transaction, like I show in the notebook, just the slide later just now. So we have the transaction ID and all was not. Let's look into the preview tab. Then you will show some sample data inside. So transaction ID is just a long string. It's being encrypted into a string already. Then you have the transaction date time, and then ID, terminal ID, and then the amount. Right. So these are the two main tables that we will be using. Then the next thing is I want to show you. Let's go through in here. So this one, right, in the reference link later, it actually contains all the notebooks here. I'll quickly go through with you. The first one is setting up the environment. Wait. Maybe there are some important information here. Should I unshare and share again? Should I unshare and share again? Sorry,
Don't worry, it happened like 3 times before.
That will stop sharing. I will do share entire screen. Okay. Okay. Cool. So in the reference link later, it contains all the notebooks and all. So you can actually go through on your own after this. But if you face any question, you just can ping me anytime. So the first one is just environment setting. You need to install the libraries and then create the bucket storage and what's not into it. So you just run it, then you can see copying the data ingestion pipeline from the source just now to our BigQuery data set. So after that, so then after running this, then you will see the data is appearing in this BigQuery table. So after the environment, right, we want to do the EDA part, right? So this is the first part that I put in. Then the rest of it, right, you can also like want to understand what is the fraudulent case percentage or ratio. Then you can also do it like this. Then you can actually from here, you can see that around 2% of the transaction are fraudulent, but the remaining, data and ML, how to do connection. Luckily, you'll remind me. I'll share again. This part. So the percentage of it, you can see that around 2% are fraudulent, and 98% fraudulent. The remaining are not a fraud. But you may think that it's only 2%. Why? You need to start a project for this, but it depends on the amount of it. 2% can be millions or billions. Right. So it's also very important. Even that's why depends on project. If you can improve your system even in 1%, the impact could be very big. Don't look down on that mini 1%. So then we want to, I'll go to the details. Here then you can see like the amount transaction in total. And then we can also plot the graph like from customer level transaction aggregate with the percentage. So then we can see like this can be like can be very similar. It can be not fraudulent, or this could be also can be fraudulent, or it can be some anonymous noise. So you need to understand your data, which one is meaning right. So this is the EDA part. I will need to speed up a bit. So let's go through the feature engineering part. So for this case, it's during the batch processing. So after running it, right, you can see what it's trying to do, right? So we understand feature engineering is just now, let's say one table, you have 10 features. Features meaning is column line. You can think it as column. One column represent one data point, right? So feature engineering is you need to select which data point is important for you. If let's say, what example? Let's say the transaction amount, it is important. So then you need to pump into feature engineering. So it is selected inside the feature engineering. But some other example that may not be important. Example only, it may still important. It could be, let's say, gender, female, male. Maybe you think that it's not giving any difference. You can take it out, or you can take it in to see what is the difference. How much the model, how much impact is determining is a fraud case or not fraud. It can be difference as in gender-wise, the shopping behavior could be different. Example only, but everything will be database. Data-driven. You cannot just have one answer for all the scenarios or all the cases. So you need to depends on your data. So we select what are the features needed. Wow, very long SQL and all. It's good that you notice it's hang. That means you follow. It's not not sleeping. You know it's not working. So it's a long sequel and all. I will leave it for now. But then you get the the aggregated data set, like what is important for you. So because supposedly that you already get this one, then you like step by step, you want to determine, let's say customer per terminal layer. So you need to have different things. So like this one is customer and terminal related features. Some customer, they are doing the transaction on the terminal, right? Some are there doing it online purchase. So some data appears in one table and the other one. So all this you need to capture it. So after that, I'll go through a long process. Then we will go for the model training. Let's see if I can quickly show you. I know it's out of time. If I can show you the feature store. Yeah. Super sorry for this user experience. But it's working, just that you cannot see it. So this is the feature store inside the Vertex AI, how it's look like. So after we do the feature engineering and all, we save into the feature store so that every time we can just, we don't need to run the feature engineering steps again. We can just directly grab it from this feature store. So it saves one process, one time. So it's actually being aggregated into like the amount of in time base. Let's say we want to have to like 50 minutes, 1 day, 30 minutes, 7 days in different windows time base. So then let's go into working, not working. Oh, yes. So then we will go for the model training part. So this one, after you run the model training, right, it will be appearing inside this AI model registry. This one is document. Model registration page. Yeah, so this is my model after train. So it's registered here. You can see like all this, how is the model performing, the precision and recall and all. So it's actually doing 83%. Okay, so then from here you can actually deploy and test and what's not, but you can continue everything on the just now the workbench notebook under the Vertex AI, and all this feature store, model registry, everything is under the Vertex AI. So it's centralized. So sorry that I need to speed up. So far, any questions? So yes.
The feature store, these all purely generated. Like
one that you store inside it's depend you are the person that determine what to be stored inside the feature store.
But just now, for example, it generated like different time windows. Is that something that you have already sorted out like yourself, or is it something that
No, it's sorted out. It's like when in, let's say in data science team, right? How do we want to tackle this problem, right? Then we want to see, maybe like we want to understand the behavior within 30 minutes, one day, 14 days windows and all. We design it in a way. So it depends on how you want to design it, your system, your detection system. And from there, you move on. So that's why I say from data to AI is a long journey and it needs a lot of thinking thoughts on before you can even implement. Feature engineering is the from the EDA, the columns are already there. Feature engineering, it can be also you are adding more columns. Let's say you instead of let's say instead of amount, you want it to be average amount, something like that. Then the average amount is aggregated data. We call it aggregated data. It's coming from some other formulas or combination of a few columns. So from it depends on it's a long process on that part. You want to see what you want to use. What are the important things that you think it can help you to detect the case better? So that's why in data science and ML, like especially like this one, right? Normally it will involve, we call it domain expert, because we don't know how to detect, right? But then you need to consult the expert, like how they are detecting it manually, what are the criteria they are looking into, and from there we translate into the software, the AI part. Yeah, we can, it is a lot of imaginations for us, but for them it's like something that let's say if you are expert in gardening and all, so you from there you directly see, you can tell, oh, this fruit is already ripe, this one is right, this one is already spoiled. You don't really need to cut and see inside, but then from where and how is throughout the experience you wouldn't aware how you see it, but then you need to determine, oh, maybe this one the smell is already rotten, something like that. Okay, smell is a feature. Then how we can get the smell? Then from there we start. So it's a journey. So interesting question. I'll give you a sweat. You already have it. So just now the feature engineering part, then we have the model training part, long process. Then cannot show much in question and answer. Yeah, sorry, time's up. We can talk later after this. Yeah. So these are the reference. If you are very interested on this one, right, try to run at home, But if you run it on GCP, right, this one will need to you need to invest some cost. The feature store and all this you will charge you. So after you run it, then you just terminate everything, stop the services and all. Thank you. I hope you enjoy the session.
Thank you so much, Lai Fong. That was very, I would say, you took us through a journey. We were being hired, part of a team. How do we do this? So yeah, thank you so much for that experience. And with that in mind, I would like to invite Amrita Navyar to do a bit of a closing.
So I just one extra point. I hope this one will feel interesting, but then I need to put a disclaimer there. This doesn't mean that you can do a credit card fraud detection after this. But you can take this as an exercise, like how you go through the process and all. Right? Because it really depends on what data you're getting. Thank you.
All right. Hi, everyone. Are you all still good? I know it's been a long day. Huh? All good? Good? Yeah? So thank you again for joining us today. I'm so happy to see all of you. You're all still here since 1 p.m. earlier. So yeah, let's give us all a big hand for being present and for all the enthusiasm you've shown throughout the day. So thank you again for joining. Yeah, so before I close today's event, I'll just quickly introduce myself. I'm Amrita. I'm a technical project manager at Google for the Southeast Asia region. I also manage the developer communities in Malaysia and Singapore. Yeah, so I really want to thank our organizers and our MC, Alia, as well today for putting up this amazing event today. So thank you, GDG Cloud KL, Bandix, Sam, and all our speakers. We have Lifelong, Kristen, and Arvin, Ash, Michael, Kiwi, everyone who joined us today. Alia, Zain, and all our volunteers today who made this event such a success. So thank you, everyone. This has been such a great team effort. Yeah, so let me just. Yeah, so since all of us are here today, I just want to wrap it up with, I just want to make sure everyone knows why we're here today. So yeah, for those of you who are not aware of this, but we have the Google I/O celebrated every year. We have this conference usually in San Francisco, right? And yeah, what we're trying to do is we want to make sure that everyone comes together, all developers get the latest updates, they know what are the latest technologies and what are the use cases that can be applied on, and make sure that you get inspired through these conference sessions, right? And yeah, so today what we're having is the IO Extended, which is something, it's a series of events that we have at every single city where we bring IO back home and make sure that it's relevant to your communities. So I really hope that all of you got what you expected today. You got the insights and got inspired through today's event. So yeah, since we're here at the IO and we still have 3 socks left, I want to make sure everyone gets it today. So I was thinking that we could probably have a quick quiz. I'll probably ask 3 questions. Yeah, but before that, I just want to share, I really hope that you guys got to resonate with whatever topics that we've discussed with. Please do share your feedback with us as well. If you have any topics that you wish to have or listen at the next event, please do reach out to us. Yeah, so this is our main goal today, to make sure that we get to help you and make technology, make everything accessible to all of you through technology. So yeah, so whether you're coming from, I understand we have a very diverse community over here. So today we focused more on AI and cloud, but if you're also into web and mobile technologies as well, we do have another community, which is GDG KL. So we'll be having more events coming up in the next few months. So we have DevFest coming up soon. So keep an eye for that. We'll be sharing that as well. And another event that we'll be having in 2 weeks' time is the Keras Community Day. So if you're interested, feel free to sign up. Yeah, you'll meet Lifelong again. You'll meet me again. So yeah, please do feel free to check it out on our websites. And yeah, so I only have 3 socks left, so I guess I'll have to limit the questions. So I think I've asked this before, so I'm not going to ask this time. Yeah. Well, so since today we covered a lot on AI, and yeah, so I have this question for you. What are the 3 new foundation models available in Vertex AI? So we started off with Michael's talk today. He did talk about our foundation models as well, and our other speakers mentioned it as well. So any takers here? Yeah, okay. Yeah, they have names, so there'll be 3. Yeah. I mean, you guys have your phones with you. You can check it out on Google. Nope. Nope. Uh-huh. Oh, getting close. Yeah.
PaLM 2, the large language model.
You got one right. So it's a team effort now. Close, but not pumped. Yeah. Nope. Anyone? No. You can Google it. Sorry? Yes. So it's a team effort. So who do I give the socks to? Each one gets one. You guys decide, yeah? Okay. Yeah, so we got those 2 gentlemen answering this just now. So we have Imogen, Cody, and Chirp. So moving on to our next question. What is the name of Google's new large language model that was announced? Yes, you can. PaLM? Okay. Someone said it. Who said PaLM 2? Did you get this earlier? Okay. It's yours. Okay. Yeah, so it's PaLM 2, by the way. Yeah, this is something interesting. What is the name of Google's new experimental AI tool that turns ideas into music? Sure. Yep. Okay. Last one. Okay. Yeah. So thank you again, everyone. I hope you had a great day today. I hope you had fun and that you got all the knowledge and inspiration that you were looking for today. Really appreciate all of you making the time to come and join us. Yeah, so for those of you, I mean, I know we've shared this earlier today as well. So for those of you who are interested in building your projects or any, things that you're inspired and you would like to get some free credits, feel free to check out this link. I'll give you a moment to scan the QR code. Yeah, and Laifong has already inspired you to get started with your own project, so feel free to use this to get started. Okay. Yes, you can start free. Okay, and for those of you who are getting started in the startup, with your startup journey, you can always check out this link as well. So if you're still new to the journey, you can go for the top one, which is the start. And the next one is the scale initiative. So you can feel free to check out whichever that's relevant to you. And yeah, feel free to scan this QR code and you get free credits again if you make it through it. Yeah, so for this one, you can't like apply and like be guaranteed to get it. So you'll have to go through the process as well. So, oh, so thank you again, everyone, for joining us. This day has been super awesome. Thanks to all of you. Oh, okay, sure. Yeah, I'll hand it over to Alia.
Thank you, Amrita. Okay, so as you may know, the day already ends and we really want to congratulate you. But before that, let's move out to outside. But first, Who here has a mobility issues? Because I believe, okay, all right, just wanting to make sure. All right, so if that's the case, then let's leave towards that door, the Wawasan 2 doors there. We're gonna take pictures first, please. Meet us outside over there. Thank you. I already sent you.
Yeah, I have an issue that, did you share with us? Yes, I'm Rachel. My employer, my company is using Google Service, so we have some issues that, I think after photo shoot, I need to speak to.
Hi, let's meet outside for the group photo.
Thank you for.
I'll be around, yeah.
Yeah.